So hopefully we're live, and this is going to be not the most exciting stream ever, even though the music is pretty hype. But what today is going to be is an important stream for business anyways. So for those who are actually doing business, things like that, this is not going to be a beginner-friendly stream, but for those who are beginners wondering, like, what does someone do in certain fields, or like, what do you do in like DevSecOps, things like that, what's NIST, anyone who just kind of wants to like see what that kind of space looks like, you can watch, check out what everything, what we're doing, all that good stuff. So what we're going to be talking about is a specific NIST draft, which for anyone who wants to kind of get involved in the commenting session, you can head over to our Facebook group. There's reasons why I'm going to be focused on just the Facebook group's chat. There will be others around who will kind of check out the other chats. So I'll try to watch the other chats, but I'm going to be a little more focused on trying to get through this NIST draft than trying to focus on other things. Now, some other things that I do want to talk about is like some new stream formats. I'm going to be changing my stream format just because it's for anyone who's tried to work with me over the past many years at this point. I have learned that my ability to be like in time, like scheduled sessions. So like I have a disability, and so my ability to be on time isn't my choice. So sometimes I've learned that it's too far out of my ability to control. That what I'm going to start doing to make it easier for others to try to catch streams is I'm going to stream like regardless, like there's not going to be a time when I stream, but what I will do is say by this, like at this time, this is when there will be guaranteed to be a recording, so that you, if you want to like catch what I'm doing, catch the recording. If you want a specific time, catch the recording. And I say this just because I don't have a choice if I can make a certain time. And so I could say that, hey, I'll be there at 2 o'clock. And what I've learned over the past, like, it's really been since about 2016 since I've had to deal with this. If I say that I'll be somewhere at a specific time, it's like a hit or miss that I'll even, sometimes I won't be able to make it at all. Sometimes I'm gonna be late whether I want to be late or not, and then the other times, then sure, great, I can make it. But it comes down to like what the state of my body's doing, which is it's a lot outside of my control. So the new format is going to be more focused on, by this time the recording will be up, but when I'll go live on this day, and days that I go live, I'm, for better for worse, unfortunately for me and for everyone, it's not going to necessarily be at specific times unless there's like someone else who's going to be involved in that stream, someone who's a little more able-bodied than me. So anytime we do have something that's going to be at a more specific time, I'll probably ask for help from someone who is a little more able-bodied to make that possible. Otherwise, without able-bodied assistance, having a time without it being a recording is so hit or miss with me that it's just, I would consider it a high-risk consideration. So getting into what we want to do today, I want to pull up some things. First and foremost, I'm going to, in the Facebook group, drop some links for basically what we're talking about. First being the document that we're going to be working with NIST. So give me just a moment, and I'm going to move my screens around and stuff. So let's see, let me shrink my face, and let's put this on the screen. And I want everyone to know how you can get a hold of this document right here. So if you go over to the cloud, if you go to Facebook and go to the Cloud Engineers Facebook group, if you're interested in being in the comments and getting these links, I'm pasting the link to this in the chat. So what's going on today, what we're doing, is we are going to be going over this draft from NIST, which is the draft for NIST Special Publication 800-204C. The purpose of this is we are going to submit comments based on our research to NIST based on what we have here. So this right here, this I will also link. So once again, Facebook group, dropping some links here. This is basically showing that if you want to provide comments directly from yourself, like you may most certainly participate in this, and I will be submitting comments based on this session myself. So if anyone else wants to do this or get involved with this on top of what I submit, then you can do more than just comment in the Facebook group, and then you can also email this right here, this email address.
Yeah, I just, in the background, want to say, for anyone not on Facebook, we also dropped those links in the description of these videos. Wherever you're watching, whether that's on LinkedIn or YouTube, you can find the draft link, as well as if you want to hop into our Facebook group and chat live with NATO on Facebook, you can find that link as well in the video description.
Yeah. So, anyways, with all of that being said, I do want to talk a little bit about also some general context as to, what do we do with all of this stuff. So let's see, just a moment here as I'm showing things on my screen. So many things. So let's see. I'm going to pull up another link with the resource that I'm going to be using that I will also share in the link in the Facebook chat specifically, which is this link right here to Olympiad Dev, because this is just a tooling resource. It's nothing more special than that. It's got like some direction as to what's going on. This is going to be a tooling kit that we maintain and update for our own DevSecOps use. So everything that we develop has basically something going on from this general foundation from what's going on here, which you may most certainly test out yourself. It's got like a whole guide in here. It tells you how to update applications, yada yada yada, all that good stuff. I do need to make some updates to it just because a few things like this section right here needs some updating. We'll get back to that another day. But what's more important right now is what we use those resources for is basically a DevSecOps based service mesh for basically deploying cloud-based microservices and applications. So this whole document is around research that is directly related to exactly what we've been working on over the past year. And so this is a good opportunity for us to also teach everyone, like, what is it that we've been doing? What is it that we've been building? And I've gotten a lot of questions of, why don't more people do the stuff that millions of people do the stuff that I'm doing. Just for those who don't do this stuff, they so happen to not be of those millions. Maybe not millions do this stuff just yet. Cloud native. How many people are in the cloud native landscape? Of all the people whoever uses cloud native right here, that's millions. 2 million. There's at least 2 million stars here. Almost 3 million. So let me go back to what I was saying. Millions of people use this stuff. So I want to say that what we do is not necessarily unique, and that I'm not the inventor of all things. And while we do advanced and deep research around these concepts, and while these concepts are new, the thing I'd like to emphasize is that these technologies are being adopted by NIST because at this point they've been tested and vetted, and people use this for business production, for basically building DevSecOps-based service meshes. So if we kind of go through this document, because this is a commenting session, and I'm going to just be doing some commentary here, on top of showing you kind of how we actively utilize these resources, which I am going to just pull up some sample tooling here, which is thinking quite a bit. But I have some sample tooling that we have from running a baseline test for testing DevSecOps-based, service mesh-based cloud applications, and I'm gonna talk about all this because it's confusing stuff. But anyways, it's all about this document. So pull up your documents. This is gonna be the most boring live stream you've maybe ever seen, but I need to kind of go through this with a eye for submitting comments. So I might be moving a little faster than I would on sessions when I'm trying to teach someone something. So right now, I am less focused on teaching anyone anything and more focused on getting through these comments and kind of talking about thoughts around that. Now, certainly feel free to stop me and ask questions as I'm going through this. And then if I seem a little confusing, certainly feel free to ask for some clarification. And some concepts I might send you to additional outside resources where you can kind of learn how to pick up some of these concepts. So let's just kind of like scroll down through this a little bit. And I know this document is small on my screen. I guess I could make it bigger on my screen. Let me do that for anyone who's going to just actually read it on my screen. I'm going to talk about what I'm seeing, but I guess I'll make it bigger. Why not? My face is in the way. I need to move myself. All right, this is a little better. Okay, so now we can hopefully see kind of what I'm looking at here. So let's take a look at the table of contents. So taking a look at the table of contents here, and I should go ahead and start setting up a... So if you're in the DevSecOps dojo, what I'll go ahead and do is collect my notes as I'm going through this in my NATO's DevSecOps Madness channel. That's to people who are in the DevSecOps dojo. So if anyone wants to directly see my comments, if you're in the dojo, you can. If not, join the dojo if you want to, but that requires applying. So security executive, or just this is a executive summary. So let's take a look at this. So introduction. I didn't want to do that. Like I said, this isn't going to be very exciting. So, so first we're going to take a look at what this talks about with the scope of what this document is and all these things, like, and then it talks about the concepts related to DevSecOps initiatives, which some of this I'll let you just read for yourself. So I'm going to be providing mostly like commentary around some of these concepts as we're kind of like going through this. So I will make comments on each section as I'm sort of like going through here. So let's go ahead and get into, so it'll be scope first, related to DevSecOps, who's the target audience, relationship to NIST guidance documents. I guess I don't need to read through all of that, so let's just get into it. I'm just going to start going through the document. Anyone can read the table of contents. So introduction, I'll kind of let you more directly read these, but I'll kind of paraphrase through it a little bit. So cloud native applications, first I'll talk about like what's a cloud native application. You could go over to what's called the cloud native landscape, and these are cloud native applications, okay? So if I go ahead and drop this in the chat link as well, then we have a whole landscape of, you know, what is a cloud native application. And some things that might be familiar in here is if I kind of look through this, you'll notice that Kubernetes is hanging out in here. And you hear Kubernetes a lot. We hear Kubernetes all over the place. Kubernetes is an example of a cloud native application. Technically, Docker is a cloud native application. There's all kinds. You can see them all here. And one of the cool things about cloud native applications is they are well categorized, and they also kind of produce context around which ones are supported more directly by the Cloud Native Foundation, where you can see some of them have gone through an incubating process and have successfully gone through, like Helm is a Cloud Native Computing Foundation graduated application. A number of incubating programs But one of the ones that I'm a big fan of is Longhorn. I love Longhorn. It's one of my favorites ever. But the thing that these show you is you can clearly see, like, oh, I've never heard of, say, Longhorn. What would Longhorn be similar to? And then you can kind of look in here and kind of figure out how to compare what things are. Maybe like an example of that for people who follow me, you probably have heard of AWS, things like that. Well, AWS is a certified Kubernetes installer. It's not the only certified Kubernetes installer. There's a whole bunch in here. We can see that Rancher's one. Rancher's one of the ones that I use most often. We have Kubernetes in Docker, so that's a Docker-based Kubernetes project. There's all kinds of things. There's Minikube in here. And in the context of all these different applications, we can see Azure is an item on here in the cloud native landscape. But it categorizes items. It categorizes applications so that if you're trying to basically build a cloud or build a project or build a product, you don't necessarily have to build, say, a service mesh from ground up with your own, like, blood, sweat, and tears. Like, that would be super stressful sounding. So instead of trying to, like, go and build your own service mesh, the idea of cloud native is that a lot of these things, someone else, there's like a whole community probably building those things. If it's open source, then it's an open source community. Not everything's open source, so if I click on something in the Cloud Native Foundation, you can see that this AWS app mesh, I don't believe is, see, yeah, it says not open source. So just because it's cloud native doesn't mean that it's open source. That can be something that can be confused. So I've gotten folks who think that I only do open source. It's not that I don't do open source or only do open source. It's that open source so happens to be pretty popular in the cloud development space, especially if there's certain things that I want to build custom, so on and so forth. And if you're building like microservice-based applications. So going back to this document, so cloud native applications are made up of multiple loosely coupled components. This is a good way to put it. So what this means by multiple loosely coupled components is that if we take a look at what's a good example here? Good example here would be Loki, if I can find it. It's in here. So if I click on, say, Loki, Grafana Loki right here. Grafana Loki is one component that I can then integrate with multiple things. As a matter of fact, I can make Grafana Loki work in tandem with FluentD if I wanted to. I could also at the same time make it work in tandem with Logstash. And one thing that DevSecOps and some of these other methodologies can confuse around is the idea that these things aren't necessarily what's the best or versus or but the idea is that use what is going to help you get a solution as fast as you can, sort of an idea. So agility is king. If you have more experience with Logstash versus, say, Loki, well, I kind of have a preference for Loki. You can use Logstash with Grafana, and you can create the same outcomes with Logstash and Grafana. And if you had different projects that different people were working on, and you were, say, using Grafana, then you could take someone's Logstash project, someone's FluentD project, and someone's Grafana project, and mash potato them all into one Grafana dashboard to make one crazy, terrifying Grafana dashboard, where you could then also add Splunk inside of it. You could add Sumo Logic inside of it. You could use them all together. You can even put Elastic in there. You could actually pretty much make almost all of these items down here all work to make one app. Now, why would you do that? I have no idea. It depends on what your use case is. Without a use case, none of this generally matters. Without a use case, all of this is, I don't know, it's it's only about as valuable as you can figure out how to make it. So that kind of comes down to just because you know how to use Loki doesn't mean that Loki is valuable. Knowing how to make a use case with Loki, that's valuable. But that's kind of the idea here, is that you end up with multiple like loosely coupled items where you can then also have, say, a bunch of containers living inside of containers, which then cloud native applications do not just refer to applications that run in the cloud. This is a pretty important thing to pay attention to. So anyone who's been following us for some time now has probably noticed that we've been working on this Olympiad project for who knows how long, and even though the green screen does weird things to it, you can see this is basically something that came from like some of our prototyping, and it's designed to launch cloud native minimum viable products, so that you can basically start with something as small as this and then scale as big as you want. You could literally have this sitting on your desk, I don't know, like today, and just start building things. It doesn't matter if it's this, it could be anything. It could be your laptop with Docker Desktop. It could be old laptop just laying around. It could be your desktop with, I don't know, put a Linux VM in it. It really doesn't matter. I'm trying to express that this is not special either. A VM's not special. Nothing's special. It's just whatever you can start building things on. Build with what you already have. That's the idea. And if you start building something with what you already have, it might not be AWS, but it can still be cloud native. That laptop on your desk can be a cloud native cloud infrastructure node. And then that can scale out to AWS or Azure or whatever you want, which kind of comes back down to understanding the value of use cases. So cloud native applications require agile and secure updates. Yes, this is important. So if we're looking at line 254, cloud native applications require agile and secure updates. I've gotten seen these confusing comments and posts at times where people are like, oh, people are expecting application developers to know security and application development, which I'm not so sure that that's the expectation here. Perhaps, say, like someone running a company might have some strange, crazy expectation. But what this kind of turns into is, because of the nature of how cloud native applications work, a lot of them are pre-built, meaning that you don't necessarily, they're low code, meaning that, well, some are low code, some are high code. So depending on what you're doing, you can be someone who knows barely any code, and you can just take a whole bunch of cloud native applications and like duct tape them together. And in cloud native, the idea that these things are already pre-made, it means that you can more quickly do things. So then at that point, almost in some ways, security knowledge is a little more valuable in terms of like helping you increase the speed of your development rate with cloud native. Because I'll tell you the difference between, say, like cloud native development is, if I wanted to build a website from scratch, let me tell you how easy it is to build a cloud native website from scratch. Like, let's say I wanted to launch a WordPress site in a week. Well, you could just go to WordPress.com, or you could get like a server and start doing all the code and doing all the staging and stuff like that. I bet WordPress is in here, maybe. Well, more importantly, if I just go over to hub.docker.com and I just say WordPress, then that's going to give me the ability to pretty much just spin up a pre-configured WordPress site. And you could find other people's pre-built things. Now, it's not to say that you should just go choose random code. It's important to make sure that things are verified or scan them, things like that, which comes back down to good security practices. Because like, while I would trust just pulling this WordPress container right here and just like duct taping it to my project, you know, I might not be so excited about looking at, like, this says WordPress development, and I don't know what this PHP unit thing is, but it shows that 1 million plus downloads have been used on this. So this is where security knowledge comes in, and this comes into like DevSec. If you don't have to develop the whole server and you're just choosing pre-built servers, there's sort of like a vulnerability assessment process when you're trying to go through deciding what are you going to pool, what are you going to decide on building your project around. Do you want to check out this thing from a verified publisher? Well, if this is from a verified publisher, maybe this has WordPress and Nginx, and it's going to be a potentially safe pre-built thing. And so, you know, with cloud native development, there's a lot of just like testing if things are going to work together. So just kind of, you know, look in your cloud, like Nginx is on here. I know that load balancing is on this. So like, I don't know if it's pronounced like Nginx or Nginx. Actually, I should say load. It's over here somewhere. So let's see. Wherever it says like Envoy and stuff like that, there it is. Service proxy, not load balancing. So Nginx. So as you can see right here, Nginx is a cloud native, open source project, or at least cloud native silver member, right? So if we're trying to get WordPress up and running in a cloud native build, then maybe this has a lot of something built into it that I don't have to understand beyond just understanding how to use someone else's hard work. Maybe it took someone 2 years to make this, maybe it took them 2 weeks to make this, I don't know. But this is made by VMware, and if it's something that I can just pull as open source and it already has some development in here, think about that as like free labor, like in the context of agility. So in this concept here, where this thing in the draft is talking about agile and secure, you don't necessarily have to know your code as well with this format of development. But what you do need to know is you need to understand your security, because the other thing is, once again, if you're using other people's code and there is a vulnerability that maybe they're not even aware of it, you know, then you want to make sure that it's secure. Whether or not it works, that's great, you know. So if you're going through just testing to see if things work, you don't even have to be good at development. You don't even have to necessarily know what's going on under the hood. You just have to know enough to launch something, make it work, and then find things that it'll integrate with. And if you can't figure that out, well, then this is where this whole landscape's amazing. One thing I will say is, like, even if we just go to, say, like, all of these different projects, Terraform's on here. So if you just Google Terraform and you go to their website, cool thing about a lot of these projects is they all have these really deep, vast communities. So if you're trying to figure out, like, oh, well, I know I want to do certain kinds of automation, think about this as now all of a sudden you're also not alone. There's a whole community here, right? There's a community forum. You can just basically just start getting involved. You can just hop into the Terraform section, start getting involved in the forum, start asking questions today, start building with people, start asking people, you know. And then this right here, it's just everyone here to help each other. Helpful people helping helpful people. It's sort of an unstoppable force, right? So we get the same thing with projects like GitLab, whatever their website is, gitlab.com probably, yeah. So the same thing with like GitLab. It's another project on here, and let's say that you're just trying to get start building, start coding, start, you know, where to start learning these things, where to find like good resources to help you get a project off the ground quickly. A lot of these have like vast communities, and I know that GitLab's resources are like painfully vast. So they have so many community resources. If you like, GitLab alone will teach you how to build a cloud. Let's say that you have no idea how to build a cloud. Just start using GitLab and just start using all of their community resources. It's insane. So GitLab for open source. You can come in here. They have all this stuff. None of this is me advertising anything in here. This is just stuff that like I'm familiar with, and you can pretty much launch whatever you want without paying a penny just by having lots of conversations, and checking out different communities. You can be a contributor to programs that you believe in. And you can try things to see like which kinds of communities are you a fan of. You might not like every community, so I say work with the communities you like. There's so many communities. So GitLab is just one of my favorites. I like Terraform, and once again, I'm not trying to isolate anything specific here, because what I want you to know is that all of these generally have communities. And that contributes to the agility of a product's capacity to be built out, because if you can have a place where you can ask questions and ask for help and ask for assistance and aid, that's almost always going to speed up the development of your projects. And if you're trying to work on something that doesn't have a very strong or very good community, when you do run into hiccups or issues or something not working well, the better the community, the faster you can get things sorted out and resolved, the easier it is to get help. The more likely it is that if you Google something, you're going to run into someone's found a solution to it before. You're going to run into those things. So we haven't really gotten too far into this just yet, so I'm going to move. This is going to be a long, boring session. So once again, we're doing this to actually comment on this and kind of really get into it a little bit. So let's see, continuing on with this, I feel like the chat is not working. Maybe it is. It's looking good. So I'm just making sure that the stream and all that on my side is looking good, so that I don't accidentally do something like nudge the stream. Okay, so everything's looking good on this side. So once again, for those who are not in Facebook, if you want to participate in the chat, the reason why I stick to Facebook is just because it cuts down on chaos while I'm trying to focus on this. So anyone who does want to get involved in the chat, you can join the Facebook group. So continuing on to the scope here, we want to kind of talk about some of the terminology. And so if we take a look at scope, the first thing that this talks about, it says that thus DevSecOps has the necessary, well, I guess I should finish reading the rest of this item up here because we were talking about like agility. So with the idea of security and agility in mind, hence they call for a different application development and deployment runtime monitoring paradigm. So everything that I'm talking about, it's different. It's kind of like I'm saying that you can build code without having to know heavy code. So that's a completely different paradigm. It's a different perspective, and the idea even of like security information and event management is not just SIM anymore. It's like observability. We're going to get into that. Like, what's observability versus say SIM? They could be the same thing, but there's some differences in the paradigm around it. So this then goes down to DevSecOps. So it's a facilitating paradigm. So for those who don't know what DevSecOps is, it's a philosophy. This talks a little more about it. You can read through it a little more. And when this is talking about the idea of a primitive is, you could think of it as like a first principle concept that is generally agnostic across like business operations. And so we're going to see the word primitives a lot, and you're going to see that in the terminology often, and that's a first principle concept. First principles, for those who aren't familiar with first principle thinking, is a philosophy around the idea of breaking something down into its most basic elements before trying to understand it at a complex level. So like if you want to become a network engineer, it's like that idea that you should learn the fundamentals first before trying to build a whole cloud. So one of the primitives of DevSecOps service meshes is CI/CD, continuous integration and delivery, and then continuous deployment pipelines, basically like supply chains. all that good stuff. So there's a good chat. So so those who are in the Facebook group, there's a good article on what's DevSecOps. So DevSecOps is a primitive for building cloud native applications, and one of the reasons why we focused on DevSecOps for cloud native is for a lot of the same reasons that this is talking about here, is because if you're trying to build cloud native applications, then speed and security is the name of the game all day long if you want it to be a successful medium that you want to use for business, especially because it can be wildly unsecure. So scope. DevSecOps primitives in theory. So I'll just read some of this. DevSecOps primitives can, in theory, be applied to many application architectures, but are best suited to microservice-based ones, which permit agile development paradigms due to the fact that the application is made up of relatively small, loosely coupled modules called microservices. So the idea behind the Olympiad follows this exact basis, which is this idea of build all of your items within a contained microservice architecture. And I'll talk a little bit about the Olympiad's containerized architecture and how we use that for our mesh distribution. And so it's definitely different. It's definitely different. So kind of going through this, and then a good comment here, Jorge. DevSecOps is a really important primitive step and covers security. So that is right. If you're operating with DevSecOps in mind, then security is included in the development process, unlike DevOps, which security is something that is generally managed from an outside perspective. So let's see. I need to start adding some comments. So I'm going to go into the Dojo chat real quick and start adding some of my comments. So I'm just going to say one scope notes. So if anyone's in the dojo, you can see what I'm typing in the chats there. But I'm just going to record anything that's basically worth public commentary on this, where I have a thought that maybe might vary from something. And then anyone who has some thoughts here too, we can add this in the comments, whatever you want. Or you can submit your own comments too, get credit where credit's due. So before describing the implementation of DevSecOps primitives, it is assumed that we have the following do this. So I'm just going to move through this a little faster because I've already gone through all of this. So do certainly feel free to read this on your own time. So one thing I want to outline here is secure design patterns for deploying and managing service-based mesh components for infrastructure, policy enforcement, and monitoring. So this is talking about some like core mesh components that you really can't really build a mesh without. And this is something that, let's say you wanted to start building a DevSecOps service mesh even just today. You are going to need to figure out like what are your general like mesh-based components. And then one of the big ones is without policy enforcement, you can't really build automation. So automation is a core piece of CI/CD, of what that was talking about, if you want to have continuous delivery, continuous deployment, all that good stuff. So then monitoring is a must because that's part of... So in the DevSecOps paradigm, monitoring is not something that you do after the fact. Monitoring is something that you build as you go. So like as you're building, there's a reason why if I go over to this... There's a reason why we have a Pi-hole running in this environment. This is a little test environment. But one of the things that it does is it provides observability around what's going on in these nodes. So we can go through like a quick observability exercise so that you can see that monitoring is something that should be done right away. And if it's done right away, it's not a time-consuming concept. I think that it can be confused. And that like, oh, but that's so much work to get your monitoring going. Not if you're doing it from day one. And I'll just kind of show you like some shortcuts. It goes back to the value of like containers and stuff. So just give me a second here. And I'm just going to pull up some concept work around just basic observability if you're just trying to like build something quickly. Okay, let me pull this back up. Wrong thing. Okay, so if we take a look at just like general activity, you can see that I haven't really been using this since I've been doing some staging a while back or however have you. But if I go and am trying to build something and I want to keep my project generally secure, then I can very easily find various projects that give me monitoring immediately. And then that's part of DevSecOps where you're developing, but you want to choose approaches that don't take your time, right? So if let's say that I have this configured to identify if something unexpected shows up in the environment here, I can come in and I can have, say, something that's, I don't even have to build all this, I just implement some, like this other open source project. I can see, you know, whatever is getting connected here, all this good stuff, and then let's say that I have something going on in my environment that I wasn't aware of. I'll show you that we can see activity. So that's gonna, if I just say, doesn't really matter what I type. So notice that this shows like there's 3 clients now, right? And then I can come in here and just 4 clients. And we can see some general things, just like basic information, right? You know, don't just start building without having some of this stuff just like along the way, because then it makes it so easy from that point forward. So that what the Olympiad does is it sets you up with these foundational pieces right away, but this is the reason why. You know, so if we go back over to this right here, I will say that right now Portainer doesn't work in this current build architecture, so I have to produce a revision just because they provided an update to the application that modified something that's used here. Not a big deal. I will change that when I get the time. But the thing that's interesting about this is it's designed in this payload delivery to automatically set you up with a vulnerability scanning tool, and then it also sets you up with this monitoring tool just to get you with security right away in the middle of like trying to build a microservice. And whether or not you start building other things, when you're trying to build a project quickly, use something that already exists for the sake of your security, so that you're not wasting your time trying to like build some fancy security solution while also trying to get your project out there, because ain't nobody got time for that. Usually there's too much going on and you just need to get your project off the ground. And while you could have magical ninja tools and solutions and the most expensive monitoring solutions on this known planet, you can also just slap something in there that gives you the same amount of security. And maybe I'm usually surprised at how many people are like have this like better than worse than tool concept for something that does the same thing as something else. But anyways, I won't get into that rant right now. I'm keeping this somewhat objective. So it's so that kind of covers a little bit of this like concept around deploying items that all of these are independent little services living inside of a service, right? So this this whole set of items, they all live inside of like one containerized microservice that has a whole bunch of different types of little services living inside of it. These are all loosely coupled services. These are all discovery services right here, and then this is a monitoring service. But regardless, loosely coupled applications, that's kind of how that concept comes together, and that's what they mean by like loosely coupled. It's like having one server that has a bunch of servers inside of it, but they're all virtual. It's a little confusing. I don't know how to better explain the concept. So let's see, tests to prove that these service mesh components work as intended in a variety of scenarios for all aspects of the application, such as ingress, egress, and inside services. So this is one of the most painfully time-consuming pieces that I usually try to get out of the way quickly. And one of the things that we did to just solve like getting this testing going rapidly without us having to like build things to test is to find a aggressive application of sorts that we could find that allows us to stress test our ecosystem. And what we ended up choosing, all of you've probably seen at this point, is, and I'm just going to pull it up, Minecraft. So I'm just going to launch Minecraft actually, just to show you what I'm talking about. Because before we start doing things, we test. So we had this tournament where we tested people connecting to the environment while running a hosted application that was actively running and all that good stuff to make sure that we have proper stability, make sure that things aren't getting interrupted, make sure things are working the way that they should. So let's see if it's here. So if we go over to Minecraft and check out our test, it doesn't matter what you're testing your environment with. And so, in my opinion, getting tests over with quickly, the least painful way you possibly can, is the best, because you just want to make sure your stuff works before tossing like production stuff in there. And anyone who's been a part of the dojo for a while, you've probably noticed the painful constant delays. It's because we aggressively test all the time, and then we find more gaps or more stability things that we need to modify. Right now, it's actually probably more stable than it needs to be for us to do business. And I'm not gonna lie, our team's pretty perfectionistic, so we basically we have put I'm pretty sure hundreds of hours of testing on this stuff now, months. We've been testing the architecture for over a year, but the thing is, this is designed to scale over a cloud native delivery. Minecraft servers are nothing new. But running a Minecraft server over a DevSecOps based service mesh, this is just us showing you can do the same things that you've seen done, but with cloud native, it's done in a different way. And then you can use other applications to test your stuff or whatever you're trying to do. We are going to be doing some weird things. So we're going to be doing things like running stress tests by just seeing how many people can be in this world, things like that. And so we'll be using things that are kind of more fun to get people even interested in stress testing, because stress testing is kind of a boring concept to begin with. But anyways, I did want to kind of touch on that a little bit. Those who are already in the tunnel have access to our test applications. Right now, that test application being Minecraft. And we are going to be launching other test applications, but once again, the purpose of the test applications is to make sure that we are following this right here. And so when people are like, well, why Minecraft? This is why. This is 100% why. Because we need to test to prove that the service mesh components work as intended. And then every time we scale, because Minecraft is something that we don't have to build and support and have engineers running and things like that, it's just something that it's a third-party supported application we just toss up into the cloud. It makes it really easy to test things. So I would say you generally want to have easy ways to test your infrastructure and make sure that your service mesh components do indeed work. You want to make sure that they scale. And that's why we are going to be doing some stress tests. So far, I don't have any, I guess, specific comments that I'm going to add to that, because this is all stuff that I agree with, or I think this is good insight here. So let's see, guidance provided. Like, this is gonna be a really long stream, guys. So if anyone's wondering, like, oh gosh, how long are we doing? Probably for at least another 4 hours at least. This is gonna be a long, dry stream. We're not even halfway there. So let's see. Guidance provided for implementation of DevSecOps primitives for the reference platform is agnostic. This is really important. I talk about agnostic concepts often and agnostic development. And in order to make like a properly coupled cloud native service mesh and a DevSecOps service mesh, the idea that this right here can work in tandem with a laptop, with a tablet, with a separate larger service, and with AWS and Azure all at the same time, that concept is what's called agnostic, or you could think of it as like universal compatibility, right? And so if we're talking about making things that are compatible with everything, the idea is like, why am I choosing certain types of applications for our tests? I want to use things that are as agnostic as humanly possible. So agnostic that, let's say that I am like, hey everyone, I want to try to get as many users into the cloud native infrastructure as humanly possible. How can we make this absolutely possible? Minecraft is compatible with like anything. So people can play it on their Switch, their PlayStation, their computer, their laptop, their server, their Xbox. That's agnostic. That's so agnostic that it's an application that works even beyond just like a computer, or even beyond just Linux. That's about as agnostic as you could possibly get. So if I'm trying to make it easier to test my platform, my service mesh, then the fastest, most effective, and easiest way I could possibly imagine is choosing an application that is has as much done for you as humanly possible, already has the universal compatibility, already lets you just like add as many users from wherever you can. And so, we're going to be doing things like testing our cloud by hosting like conferences in a Minecraft world, things like that. We're going to be doing all kinds of strange things. But there's a reason behind it. Anyways, let's see. Service mesh software. Policy enforcement. So I'm going to go back to just highlighting this policy enforcement piece right here. Policy enforcement is probably the most painful journey, because policy enforcement means that the first thing you generally have to do is white paper things out. And so the beginning of our Olympiad policy enforcement started here. If I go all the way back to Notia Point's website and go over to our DIY resources where I launched the foundational concepts, this is the beginning concept of building policy enforcement. I usually start it with a white paper. You'll notice a lot of companies start with a white paper. So if you're trying to get like a cloud native project off the ground, white papers are so easy to start with, in my opinion. I'm sure there's other ways to start a project. I find the easiest way to start any application is a guide. If you write a guide, then your guide becomes policy. Then you take the policy from the guide, and then you enforce that, and then that's called automation. And then we call that policy enforcement. So I'll say that again. Or at least I'll try to figure out how to say that again. So if you want to make an application, writing a guide builds an application. Then if you then automate the guide, or the guide is the white paper's policy for an application basically, and then the enforcement of what's in the guide, that's your enforcement. So I would say that this is the policy that Olympiad Dev over here was built on. So Olympiad Dev follows the policies proposed here in the Olympiad white paper, right? And like, this is how conceptual flows work, right? So if you're trying to work with these things, then you want to start with policy first, because policy is how you automate. And if you don't have policy ever, I don't know how you would build automation without policy. I'm sure it's possible. Maybe someone's probably genius enough to just like do it off the top of their head without building out. But you still have to code the policy the second you code. Anyways, but yeah, I guess yeah. I also like white papers for building policy because they also allow you to share. And we use this white paper to let the white paper get heavily tested before we even started developing. So by the time I even got to building Olympiad Dev right here, we had maybe like 10 months of aggressive white paper testing from, at this point, like hundreds of people. You know, and all of that testing goes into saving a lot of time and money. Because then you know what works and doesn't work before you even start doing the build, and it saves you time, and anytime you save time in business, it saves insane amounts of money, because money doesn't fall off trees. And the most expensive thing in development is generally labor. Infrastructure can cost a lot too, which is why I recommend like start with what you have. You don't have to have something like this. You can. You don't have to have a big beefy server. You can if you want. Just what do you have? Do you have a laptop? Great. Start building on it. Oh, great. Now you have you built a application. Scale it to whatever you want. You could scale it to servers. You could scale it to AWS. You could scale it to Azure. But I think it's important to come up with the architecture and how that's going to be designed before you get that far. And so before we started deciding how we want to scale in the first place, before we started building or trying to attempt to scale, we wrote it all out first, right? And that is the process of policy enforcement. And then by the time you save that, the Olympiad Dev, believe it or not, is a policy enforcement module of the Olympiad white paper. So I'll say that again. The Olympiad Dev container is a policy enforcement module of the Olympiad white paper as a policy. It doesn't mean that mine is a better tool than someone else's. Someone could make a better application than what I've made, but this is the concept flow, right? Regardless of, anyone could do what I do if you understand how it works, and so you could make your own version of the Olympiad, or a different version of it, or your own flavor of it. It doesn't really matter. If you know how it works, you can just whip it up, right? So let's see, the reference platform. So whatever platform you're building, that's going to be a reference platform. Our reference platform is the Olympiad. There's tons of reference platforms in the world, along with DevSecOps implementation components can therefore be looked upon as having the following functional elements or code types. Now, one thing that I don't know if I talk about much, I do talk about, if you watch enough of my content, I talk about like what exactly is the Olympiad and why did we build the project. It is also a cloud-native DevSecOps toolbox. That's what it is. So it's designed for implementing your tools and maintaining your tools and then executing them. So if we take a look at this, the application code, which contains the application logic for transits, and actually I think I do need to make a few notes on some of this, so I need to take a break and do some commenting. So let's see, that's line 280 through 283. So bear with me while I make some comments. So this is under scope. It's gonna be a long stream. So let's see. Lines 280 through 283. Okay, so what I'm just talking about is basically coming up with like stress testing methodologies from like code or applications that can be recycled, like something that someone else did. So let me specify that from code. Example using pre-built applications like Minecraft for stress testing. Okay, so I'm making some comments. So let me continue on here. So let's take a look at these. The reference platform, blah 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 blah. The application code. The application code, which contains the application logic for transactions. So if we're talking about building, say, like a continuous deployment platform of sorts, or building something that works for continuous deployment, like if we're thinking about using applications like GitLab as an example of a continuous integration and continuous deployment tool and platform, it's a great one if you've never used GitLab. There's also like GitHub, things like that. Technically Docker Hub as well. But whatever your code is contains the whatever the logic is. So application code. Let's take a look. And then service mesh code. Now the difference between your application code and your service mesh code is your service mesh code is more designed around like your networks and like your load balancing, things like that. So there's platforms like there are resources like traffic or Nginx, or like if you're talking about like proxies, things like that. Then your infrastructure, whether it's infrastructure as code or physical systems, and then also that kind of comes down to policy as code for generating rules and configurations. So if you're building like authentication and authorization processes, like policy as code processes, we just started automating our policy as code processes. So some of you may have noticed that we said that we would provide credentials for getting access to cloud resources in our ecosystem, and then it took like longer than I expected, like 2 weeks. That was me building out policy as code with the team, which just required a little more work than I maybe expected. And then finally, observability as code, basically like software for doing like tracing, all this stuff like that. One of the reasons why I use Pi-hole first and then I add Loki and Grafana later is all for observability, and like Prometheus and stuff like that. So anyone who has used, say, like Grafana with Prometheus, you can also add things like Logstash to Grafana Prometheus stack. Loki does what Logstash does, adding observability to your resources, and then automating your observability as code. So what observability as code is, just like pre-configured observability. This right here is pre-configured observability. Now this is just like fastest off the ground that I currently use, but the more code we build, like we're going to be using more robust dashboards than just purely using, say, like a Pi-hole, right? It's a lot more complex than that. But you can see like packages getting installed, like right here. Like I know that this deploys a Metasploit package, but if I didn't know that this deployed a Metasploit package, I might look at this and be like, whoa, there's a Metasploits being deployed on our network. What is going on, and who's doing what with it? And I might get concerned. And so this right here could be like a red flag if this wasn't like a demo environment or a sample environment for what we were testing and experimenting with. And once again, it's like the idea of getting things off the ground as fast as possible, that's important. So anyways, application as code, like that's the code and logic for your application. Service mesh code, that's the stuff to basically like couple your, manage your load balancing. I would say the thing that, in my opinion, is probably the most frustrating to navigate is the load balancing components. There's a lot of load balancing that goes on, like a dizzying amount of it. Some of it we use AI for because I don't want to deal with it, which that's going to have to change at some point, or we'll have to make our AI more robust. But, you know, there are different things that you can do to save time, too. And if that means using AI to speed things up, maybe I should make a comment on that. You know, I guess your policy as code can also be accommodated by AI. So can your service mesh code. I guess it's all related. Maybe I should make a comment on here for like 290 to 301. Does operational AI have a place here? Let's find out. Let's see. 290 through 301. Does operational AI have a place here? Now, I am going to be doing a test with operational AI because we use we have such an interesting network. That's the most I'm going to say about it. Let's see. Let me paste this thing in here. So I'm doing an experiment with operational AI. This may sound silly, but it's actually you can do quite a bit with it. It's called a Ponagachi. So I will just add that in the Facebook chat link. Now I'll pull it up on the browser here so that you can see what I'm talking about. So I'm so curious about this. So this is a BetterCap based tool that has some things where you can actually build these things to not require a Raspberry Pi. You can actually build them into a cloud pipeline. And if your cloud pipeline, one of the number one vulnerabilities in your cloud pipeline is that your mesh most likely is going to have multiple routing systems potentially. And so it's really hard to figure out how to have the time to handle all of the vulnerability management of that, and I couldn't figure out a better way to manage the vulnerability management with that, so I am going to unleash AIs on it. And you can too. And it will tell you all kinds of things, and it will also crack hashes on your stuff. But do this on your own stuff. Don't do this to someone else. I'm using this for pen testing purposes on my own stuff with AI and automation, because you don't have to do everything manually yourself, and then it also makes faces at you as it hacks. So I mean, who doesn't want this thing making faces as it's cracking your stuff? And then if you find out that you have something that was easily cracked on one of your routing systems, then you'll know before, probably faster than someone else can get to it if an AI is doing it. So anyways, this is just something that I would like to make some awareness to. There are, not this tool specifically, I didn't make that tool. It just kind of goes back to the fact that there's so many random resources out there that you can use them in your pipeline if you have a purpose or use for it. So anyways, that would get into the realm of what's called chaos engineering, is having something constantly pen testing your stuff and causing chaos while you're doing your stuff. So let's see. Is there anything else I want to comment on in here? So this document, for example, in the case of infrastructure as code, the declarative language models, servers resources, blah, 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 manifest stored in the servers, blah, blah, blah. Okay, that's fine. So anyways, moving on here, you can read some more of that on your own. Getting back to more comments. Let's see, comments I will make. So I am on 1.2 related DevSecOps initiatives notes. Okay, so I'm going to talk a little like a little more lightly about this section here, because this is just kind of going into some initiatives out there. So I'll just skim through this a little more. 1.2, so related DevSecOps initiatives, DoD Enterprise DevSecOps Initiative. This kind of talks about some things going on. Basically, the Iron Bank, a repository of DoD vetted hardened container images, Platform 1. So what this section means to you is if you're trying to figure out like how do you find a job doing this stuff, this will point you straight at some government entities that do it if you want to start there. And then obviously there are a lot of companies who use these kinds of technologies. So let's see. DoD Enterprise. The DoD Enterprise DevSecOps Initiative has the following state practice ingredients. So this is probably worth just knowing in general. So if we're thinking about like how does the DoD Enterprise see DevSecOps, then one of the categories is abstracted. So that's basically that things are to avoid drifts. It must be agnostic. I've been talking about agnostic, and that's a big deal. So things like Kubernetes help contribute to making things more agnostic. There are tools like BuildX, things like that. GitOps, infrastructure as code, all that good stuff. So this says basically no drift, everything is code. Really, in a DevSecOps mesh, everything should be code. Whatever you're doing, code it first and then test it. It's a little different from like other building. Like if you're building monolithic, you can just sort of like size what you're trying to build, and then you can just start building things and putting it together. Because cloud native resources are designed to scale and DevSecOps meshes are designed to scale, you need to be able to easily scale up and scale down. And if the automation isn't built from day one, it can mean that like up front your development processes can take a little longer, and then after a while they speed up once the automation's done. So sometimes like building your GitOps infrastructure can be real pain, and it can take a while. And that's another thing that has taken us more time than actually implementing things too. So it's like you'll spend who knows how long building out your infrastructure as code. For example, this is infrastructure as code. This whole thing right here, where this deploys infrastructure. And this infrastructure is GitOps ready, but you have to bring your own Git. So as this kind of shows right here, it even talks about how to add your own Git, which I need to, once again, I need to update this container resource because there is a recent update to Portainer that I got to just modify this. But anyways, we made this a bring your own Git design in the infrastructure as code so that it's poised to be used as GitOps infrastructure, right? That's what this is poised to be used as for anyone who is kind of trying to get examples of these resources here. So your GitOps infrastructure, that is something that has to be designated, but ideally if it's something that can be coded, that's ideal. So you want codable infrastructure. And then, so that's kind of why we use some of these examples. Now, continuous integration and delivery pipelines. I love GitLab. There's so many different ones. We can take a look at them in the cloud native landscape. You can see continuous integration and delivery. I don't think there's a wrong answer to what CI/CD you use. I think it's somewhat personal to what your project is. I've heard good things about Jenkins. I've heard great things about Argo. I love GitLab personally. I'm sure Flux is amazing. I don't even know. So, and the concept of agnostic also kind of covers this idea that something is only as good as the use case. So if GitLab isn't as good as, say, a use case for Argo, in some cases you can even mix and match. You could say, I'm going to use Spinnaker and Argo together with Jenkins. And so just because you use one of these tools doesn't mean that you might end up using multiples of them together to better meet some form of a use case, whatever you're trying to accomplish. And once again, it's kind of unique to what you're trying to do, whatever you're trying to do. So, getting further in here, hardened containers. What in the world is a hardened container? So harden Lego blocks to bring the options to developer teams. This container here, Olympiad Dev. Olympiad Dev is a hardened container designed for putting your containers inside of. So it actually runs Docker inside of it, and it actually is also able to run Kubernetes inside of it as well. So if you're trying to run a hardened Kubernetes layer, this will let you deploy a Kubernetes layer that's hardened by Docker. It's also Alpine Linux based. So if you're deploying hardened Kubernetes Debian based images, then if someone then were to inject a Debian based attack on the host here, then that attack would not be compatible, meaning that this node will not receive the impact that the components inside of it received or are vulnerable to. So that's like the concept of like hardening, or at least that's one of many ways. There's so many ways to harden. I don't think there's like I'm sure there's a right way. I don't know. The right way is to block ports and also minimize additional vulnerabilities in certain ways. But I would say it's a little more complicated than that. I don't know if I could explain that very quickly. Software testing. I've been talking about testing this whole time. Test all day if you have to. Our Minecraft server, why Minecraft? Because it runs 24/7. It never goes down. We don't let it go down. If it goes down, I need to know about it. If it went down, I need to know why it went down. I need to know every single detail about everything that took it down. Test every single thing you can, because the application you're testing matters less than whatever the value of the test is. So for us, our value is I need to know, like, is this environment going to be stable enough for like production use, and is it going to be resilient, all that good stuff. We have a lot of resiliency. So anyways, software testing, baked in security. We've been doing that. I've shown you the monitoring thing already, like launch monitoring, and as like right away. There's no, I'm pretty sure there's no, the only wrong form of monitoring is to just have none. Like I'm sure there's more optimal ways to monitor, so on and so forth. But the way to do monitoring wrong for sure is to just not even have it. So if you have no monitoring, figure out whatever figure out whatever you need to do to get monitoring. I think that's just the point, period. And then chaos engineering dynamically kills, restarts containers, we are going to be doing a lot of chaos engineering. We even started a small education-based company inside of the DevSecOps dojo called Chaos Labs Inc. And it started off as role plays, and then we got so busy that we just decided to start just doing business and showing business, and here we are. So this is just me doing business live this time for things that we need to do, because I need to comment on this document. And then let's see, chaos engineering. Yeah, destroy containers while things are running. Target audience. That's not really something we need to talk too much about. Now, if you're trying to build a business around this, then whatever this target audience is probably your target audience. And then why is it that I am so focused on this, and why do I say that this is an important thing for the business needs of what we do? Is because this goes to our exact target audience. It uses our same target audience. It shares our target audience with us, and all of our general payers who are business practitioners have to abide by NIST. So, since DevSecOps primitives span development, build, and test for security, you can read what this is. Basically, it's just saying software development, operations, and security teams. Relationship to other NIST guidance documents. These are some other documents that you can read. NIST has a lot of fascinating things. These are probably all worth reading. There's security strategies for microservice-based application systems here. They have something based on building secure microservices. Attribute-based access control for microservices. using service mesh. And this is sort of based on a lot of these concepts in a way. Organization of this document, this kind of covers just how is this document going to be organized. This is pretty standard for what I would expect from a NIST document. And I think that's all the comments that I have on this section so far. So let's see. Reference platform implementation. So container orchestration. So I'll just read this since I'm reading it in my head anyways. A container orchestration and resource management platform that houses both the application code and most of its service mesh code. And then the service mesh software architecture. Once again, that's exactly what the Olympiad is. Now, once again, this is coming out of it's kind of an alpha phase. I should probably note that this is an alpha phase right now. But this has our service mesh code inside of it, or at least the foundations of it. So as I work on this more over the next year, I'm going to be building a lot more of these specifics into this so that it matches a lot of the things that you see people working on. And then, yeah. Notice that it's all in a container. And notice that we run Docker inside of a container too. There are reasons for that, and this proposes that same concept of put your Docker engine and all of your Docker applications all in, say, a single container, and that you can think of as like microservice engineering. Now, let's get into section 2.1. I got to get back to taking some notes, so 2.1. Okay, since microservices are implemented as containers, a container orchestration and resource management platform is used for deployment operations. So the idea here for like orchestration is that if you're using like containers for your orchestration and it's all infrastructure as code, scaling up and down, it's easy to orchestrate. Kubernetes is good for that, so Kubernetes is a way to manage that. Thing about Kubernetes is Kubernetes automates a lot of the pieces that, say, Docker doesn't. So while we use Docker to build images, the same images built here can be then deployed back into Kubernetes. So even this right here can be deployed into Kubernetes. And the way that we kind of are working on managing our implementation right here, which is like adding edge computing to the platform, is that we have this designed to, say, install Longhorn, which is a Kubernetes-based application. And then this is designed to live inside of Longhorn. And if you're wondering what Longhorn is, it's basically like an S3 bucket. So we kind of just like build our own kind of version of what is kind of like an S3 bucket. And yeah, that's one kind of good way to think about it. And maybe this is one way I should start explaining it to those who are unfamiliar with the concepts. Because while Dojo members are like, oh yeah, this makes sense, for those who are not Dojo members, like a good way for me to put this, as Jorge kind of mentioned, is it's like a cloud inside of a cloud is what NIST recommends. And so that's another thing that helps make things agnostic. So the idea that this container right here can run inside of this, and then it can also run inside of like some other big machine, and Longhorn will run in all of those. If the cloud lives inside of a container and all your applications, everything you're doing lives inside of a container, then your cloud is portable, and you have a portable cloud that can live in any cloud. So that is kind of a good way to put it, is that it's like a cloud within a cloud as proposed by NIST. And so then what this does is it makes your development more agnostic. And then you can, whether you're using Docker or Kubernetes, a container image is going to work as a container image. And then this even right here deploys Kubernetes inside of it for a reason. And so I like using the K3D project for things like in terms of doing something quickly. I feel like K3D is so fast. I love K3D. It's like one of the fastest ways to test your like scaling code, because you can set up entire clusters of however many nodes you need to set up, and then just like sprinkle it across your service mesh nodes. And then Kubernetes automatically will try to scale your applications to like multiple systems, and it will automatically add levels of load balancing. There's a lot more to it, so I'm dumbing the statement down. So for anyone who is thinking about this at a much more advanced level than that, I'm just leaving it at the dumbed down explanation. So anyways, some other interesting things about like groups of pods. A node might actually be a virtual machine, and it doesn't necessarily have to be a container. And a node can also be a physical piece of hardware. And so orchestration has to be something that has to be also agnostic from being exclusive to containers, to where the code, in theory, is going to then be something you can use on virtual machines or on bare metal systems. And then also an interesting thing about virtual machines is virtual machines can be used to basically use infrastructure as code from containers to then generate, say, like a virtual machine. Well, then why would you do that? Virtual machines don't use daemons for communicating to the hardware, which means that virtual machines have direct communication access to the bare metals infrastructure, like underneath a container. So if you have containers that do things like generate virtual machines, then that's also a way to like have, say, like infrastructure as code that can communicate with hardware, if that makes sense. Anyways, all the things. So I feel like there's something that could be outlined here on 2.1, but maybe this is a good way to put it all. Let's see. Yeah, constitutes a group of. Yeah, it includes the points. So like one of the techniques used is horizontal scaling. So this concept I just mentioned is horizontal scaling in concept, where microservices that are accessed more frequently are allocated higher resources. So yeah, it kind of depends on how you're designing your stack, or how you're designing your cloud. I'm already getting so tired going through this document, but we're doing it. I'm going to keep going. So anyways, let's see. Security limitations of orchestration platform. Orchestration platforms, if they're not automated and orchestrated enough, or like let's say that your orchestration's not well secured or protected, then you have a massive vulnerability where people can basically just take over your entire cloud. SolarWinds style, I guess. Let's see. So this kind of covers some things. I'm just kind of, at this point, I'm going to kind of do a little less commentary, think through this a little bit, see if there's anything that I care about, just so that I can get through a little more of this commentary. So TLS, not an easy way. Now, this I agree with. Examples of secure communications between Kubernetes pods. These are not natively secure, since there's no way to enforce TLS between the pods. Now, this is an interesting concept. I guess I will commentary lightly on this too. You want to think about how your orchestration security is managed, because, for example, if you are running Kubernetes tests, if you're running that, once again goes back to the reason why this isn't a hardened structure, is because if I have activity happening within this structure that's not encrypted, then I just have all this like unencrypted traffic flying around my network. And my test application does, which is another reason why I've kind of delayed some things. And so then you just have like all of this like vulnerable information just like floating around if you don't contain it in a structure. And hardened structures are great for that. So that is like, why would you run Kubernetes in Docker? because you can use Docker to basically load balance and manage ports and also do things like force TLS for access to a certain, say, Kubernetes resource. There are all kinds of things you can do. So that makes sense. I agree with that. Let's see, rather than it's going through. Yeah, you'll run into a whole lot of HTTP traffic with resources like Kubernetes, things like that. There are reasons why you don't want to go into a coffee shop to be the place that you're learning how to use Kubernetes necessarily. If you are opening random ports on your machine, do that on your home network or on a business network. Coffee shops can be bad places for that. Or use a VPN. If you're trying to do development like publicly and you are working on HTTP resources that you're not sure if they're showing up externally on your system, or maybe you do some port scans on your own system and notice that you can see your own ports available from like your cell phone to your laptop that you're doing development on, because you can do port scans to your laptop in a coffee shop to see if someone else is probably going to hack you or can see your work. And really the easiest way to get around that is just use a VPN when you're going strange places. So if you're in a hotel, if you're at a coffee shop, just use a VPN. I wonder if this talks about that. I might comment on that actually. Security limitations. Well, this is just proposing limitations, not necessarily solutions. Yeah, this makes sense. I feel like I should make a comment on it, though. Well, let me make a comment on this. Okay. So basically, if you're doing remote development, just in general, remote developers, like VPN kind of solves a... It's not like an end-all be-all, but it's like a better than nothing way to kind of just don't go have open ports at a coffee shop. I don't know. Service mesh software architecture. Having looked at the various applications, services required, the service mesh software consists of two: the data and the control plane. So this, I have found, confuses people. Don't tell people that you're building them control planes, because then they'll be like, you're building a what? Just don't say the word control plane to people. They either won't believe you or get confused and then think that you don't know what you're talking about, just because they don't know what that means. So Kubernetes is something that lets you develop control planes, and Docker lets you control control planes. So, anyways, so when I do things for a while, I have random things. So if my face does stuff, it's beyond my control, and just ignore it. Okay, so let's see, service mesh. I will be right back. I have random things that happen to me sometimes. This is why I don't set specific times for meetings, because then I'm just like, I can't actually see anymore. So I will be right back. One moment. All right. I have random things. It's random, but it's okay. Okay, so getting back into the stuff. So control planes. A control plane you could think of as basically the plane of which your nodes in a service mesh communicate with each other and talk to each other. So you could think of it as like a communication layer that allows also like the deployment or injection of your deployment code. So like you could think of a control plane as if I have a location here and then another location like in another country or another state or another place down the street, doesn't matter where. And let's say that I want that all those locations to operate as like one location, like as like one giant server. Like, hey, this is all just like one environment. The thing that unites the environments would basically in concept be control plane. I guess that would be the way that I kind of try to explain it. I'm sure there's probably better ways to try to explain that. And so, anyways, I guess this explains it a little more, is the data plane component performs 3 different functions. So, secure network functions. So this is where we have our functions. There are platforms like OpenFOSS, which are good like serverless function tools. And then also policy enforcement functions, data plane, observability functions. All of that is data plane stuff. I feel like this does a better job of explaining it than I do. And control planes, I feel like also this does a better job of explaining it than I do. The control plane has several components. So the components in here, we have our service discovery and configuration. So in the context of like proxies and pilots, this is basically something that can also, you could consider it a part of load balancing. So if you're doing load balancing, Envoy is a cloud native proxy solution. And then, automated key and certificate management. So we call that like the pilot, the citadel, the mixer, galley, ingress gateway, egress gateway, all these different things, sidecar injector. And so when we're talking about the concept of having loosely coupled components, this is how your components are loosely coupled. And so your data plane basically has the rules of how the data is going to work and how its functions are going to function, right? The data plane says, how is it going to function? And then the control plane is a little more associated with how does the machine basically move data around and orchestrate everything beyond just like the functions, because it's kind of all works together. So that's something you can spend a little more time reading about. I'm kind of curious because this specifically calls out Envoy, which seems like a good solution. An interesting thing to take a look at here, and maybe this is something that's worth commenting on, and this is something that caught my eye, is maybe this means I need to learn more about Envoy, which it could simply mean that. I've been spending some time playing with Envoy because I have a little more experience with, say, like Nginx at this point, or Traffic even. I think Traffic is what I have the most experience with at this time, but where is it? Oh, here it is. Okay, so Envoy. Let's take a look at it. This falls under the service proxy category. And effectively, if you're trying to build, say, a DevSecOps-based service mesh, then you need something that's going to handle like proxy management. And Envoy, I don't know if Sidecar is specific to Envoy, or if what the concept of Sidecar is or does is something that, say, Nginx or any of these others also can do as well. One that's built into Kubernetes by default is Trafic, which also is a load balancer and service proxy that can be used separate. So I do have some curiosity if anyone even knows something about this. Can you accomplish the same sidecar functionality with Envoy that you can with Trafic, or for that matter, Nginx? And I've been seeing Metal LB a lot as well. I've played with it and I didn't like it, but maybe I need to revisit it. But then once again, I don't know if Metal LB is able to do some of the same things that Envoy can do, and kind of what sets that apart from some of the others. So that is a thing that I'm curious if anyone knows anything about. So I guess I might even make a comment on the NIST document to them, just around like, is the sidecar functionality for a sidecar proxy? Can you build a sidecar proxy, or at least a similar architecture with some of these other load balancers? That's something I am testing too, so I'll have an answer to that directly from stuff as well soon. So let me go ahead and pull up my notes, because I want to take a note on that. So this is section, let's see, what section is this? 2.2.2. So anyways, I guess I just need to see a little more like this sidecar proxy architecture, what sets it apart from other like proxy architectures and designs, and then that would answer the question of, does it have to be Envoy at this time? Maybe, I'm not sure. So that's something that we are putting some time and research into, just because it's all stuff that I've touched and played with, and what this does provide some articulation around the concept. So I guess then the question is, like, what are those differences? What are those similarities? And for this one, I might even see if, I don't know if anyone said anything in some of the other chats, because I haven't been following them. But I guess I could pull them up to see if anyone has any thoughts on that. So nothing on any of these so far, which is just fine. All right, so I don't see any comments right now on anything about what I'm asking, I don't think. Or wait, maybe? Oh. Oh yeah, sorry for those who haven't been getting approved.
I approved member requests, so...
Amazing. Okay, so anyways, let's see, continuing on as we get past sidecar proxies. I have been spending so much time with proxies development lately, so anyone who's into proxies, I've found like a fascination with them. I think proxies are pretty neat. I don't know why. So anyways, DevSecOps, organizational preparedness, key primitives, and implementation. Looks like we're about halfway through this, which, well, not even halfway, so we're making progress. We're making progress. So DevSecOps incorporates security into software engineering early on in the process. So this is accurate. Software engineering, security. Security has to be a part of software engineering with this. Now, I talked about this a little earlier because this is one of those pieces where I've had conversations around this, and there's a misconception, I feel, in the cloud native computing landscape with those who aren't familiar with it, where folks who are maybe more familiar with, say, monolithic development, coming from some of these other development formats into cloud native, normally there's all this legwork that you don't have to deal with in the landscape, because the landscape, it kind of goes back to, there's a lot of things built for you. So instead of building something from scratch, if you're trying to do what, say, any of these tools do, especially an open source one, if you're trying to recreate something that, say, etcd does, whether or not you know what etcd is, with the cloud native landscape, before just starting to build something, look to see if someone else has done it first, because it will save you significant amounts of time. Amazing, incredible amounts of time. And what this then means is security becomes more possible because you can spend less time on development. And then I will say the downside of that is sometimes custom coding has to happen later. And so it's kind of like a front-loaded, like, make the thing work first and then make it look how you prefer later. And it could just mean that your minimum viable product, if it's a cloud-native product, is a bit of a Frankenstein, like, terrifying creature where it's, like, made from all these different things just, like, stitched together. And maybe it's, like, taking a teddy bear and then, like, putting, like, a stuffed rabbit ear on it and then giving it, like, the leg from, like, a stuffed dinosaur or something. I don't know, making something crazy out of it, like a crazy Build-A-Bear thing. I don't know. I'm just making crazy examples now. But the point being that you don't have to spend as much time on software development, making the capacity for security not as time-consuming as it sounds. And it does mean that you don't need to know as much about software engineering, and it also means that in theory, you don't have to know as much about security either. But what you do need to know is how to work with done-for-you resources and how to stitch done-for-you resources together. You could think of it as like clip art coding. And then you start with the clip art version, and then you go later on and then make like a beautiful, glorious UI for it another day. That's kind of how I see cloud-native development at its finest. And then that way you can monetize something to earn the money to pay people to make it look pretty. But the reason why, it doesn't mean that you have to be a master of all of the above. I think I see that misconception all the time. Cloud native swoops in to say you can be a master of none, and you can be a masterful coder and security professional with a fraction of the knowledge, a fraction of the effort, and a fraction of the time. And it sounds, in other ways, that's like, oh, but that's like all this extra work. No, it's not actually. It's much different. Maybe different is the way to put it. So it integrates and automates the security process and tooling. This kind of goes back to, like, why is it that I just slap the Pi-hole on it as like a base tool that's just there from day one? You need to have automation and security tooling like in there right away. Have that in your workflow. Like, it's just got to be in the middle of it. Did I have to build and code Pi-hole myself to invent it? No. I just take someone else's stuff and stitch it in there. And then when I need a new security feature, I'm going to stitch it in there too. And so anytime there's something that you don't know how to do, Google and stitch in someone else's hard work instead of your own. And don't even outsource it, because that's more work than stitching in something that's even more further along than that. In a way, it's kind of like outsourcing something that was made. Just don't reinvent wheels. Don't reinvent wheels. And the cloud native landscape is designed to help you not reinvent wheels for your sanity. Because you will go crazy if you think that you can keep up with the market when everyone else is like stitching things together while you're sitting here spending 6 months just trying to build a container registry. Don't spend 6 months trying to build a container registry. Go find one that's already built and throw things in it. Some might disagree with that format, but in the cloud native landscape, do it in a secure LAN. It could be isolated. It could be even a dark site where you don't make it connect to the internet except for things that you like connect from a separate drive and plug it in if you're that worried about it, and make something that you don't have to build from ground up. That's kind of the whole idea of why this is possible and why this is not as much extra work as it might possibly sound. So in other words, it can be looked up upon as a combination of the three processes as development, security, and operations. This discusses the aspects of it anyways. So kind of looking at some of these aspects, so preparedness, organizational preparedness. This is a thing that we spend a lot of time on, is making sure that things are prepared. So before you start trying to productize things, anyone who has been in the DevSecOps dojo probably noticed that before we ever even had the Olympiad dev container here, before this ever existed, we didn't really have infrastructure that we let anyone use, not really, because we needed to make sure that we had something that was fully portable and fully modular and 100% code and fully coded before we even start doing anything. And what it did turn into is, it's like, that was, how long did it take us? So I think it took us 10 months. And what was the size of the development crew? The dojo members, a lot of dojo members pitched in. So, like, if any of you are fine with me calling out your name for who all pitched in, there's quite a lot of you who pitched in. And then our core development team has been myself, Jordan Anderson, and Randall Massey. And it has taken our team of 3 about 10 months to develop basically this foundational resource that now takes perhaps like any of us 5 minutes to launch. Jorge was a big part of, so Jorge said I could say his name, so look up Jorge Abalo, he's on LinkedIn. He's a developer and resource creator, all those good things, works in the security space, outstanding resource as well. And then if any other DevSecOps dojo members chime in and are fine with me saying your name, for those who've been a part of all of our research, once again, it took our whole crew between like research, review, testing, letting people test, having people help out, having people throw in the ideas that help us make this possible. Like 10 months. I'm trying to think. Yeah, it takes a while. But the thing is, now we have this forever, and so we can just like launch it out there. And now we have to just make trainings, so we have all these trainings we got to make now. Great. But it's much easier for us to make the trainings when the platform takes 5 minutes to deploy now, right? And we can build whatever service meshes we want from the core architecture. It's basically a template. You can cut the things off you want, cut out the things you don't want, add the pieces you wish you had. And that's kind of the idea of organizational preparedness, is that I know that we as a team aren't going to be capable of being appropriately prepared to accommodate production and users and all of these things if we don't have our policy as code quite literally like coded in, so that everything's precise, and where I'm not going to have to worry about human error when I deploy this, because if there's something that's off, I guess there is human error. I could like have a misconfiguration, but if I have a misconfiguration, I just tweak one little thing and then it deploys the fix to the misconfiguration to all of my infrastructure. Even if we get to a point where we're at like 100 nodes or 1,000 nodes, then I need to have a way to be able to manage all of those nodes remotely. And this even has a process for... Now, this update process has already been modified, so right now, like this was our original update process for like the easy way to update it is you just do this, and it lets you update it. But we needed to make it so that things could be easily updated, easily remotely orchestrated, rebuilt if something happens. Like, what if someone hacks one of these nodes? Then we can literally just like whack it off like a starfish limb and it'll just like regenerate itself, right? So even if someone were to like heavily corrupt a single node, we can generate nodes at scale. And that's part of what chaos engineering is for too, where we're going to go out of our way to actively attempt to destroy nodes while it's running, right? Like that's chaos engineering. Is like, okay, let's attack these nodes, let's test their stability, let's try to infect them, let's try to do things to take these nodes down. We're gonna be attacking our own environment constantly. This is called chaos engineering. And it's even in this listing up above here where it's just like chaos engineering. So chaos engineering dynamically kills, restarts containers with moving target defense. And we're going to be using the little Ponegachis to help with this too, because we have some WAN-based nodes. So we're going to automate some of our chaos engineering with Ponegachis, and then we're going to also be doing chaos engineering with other means and other formats. Just constant assault on your ecosystem. But once again, if your preparedness This is important. Organizational preparedness. This is just really relevant and really important, and it even says this smaller team not only promotes efficiency and effectiveness in initial agile development to deployment, but also in subsequent lifecycle management activities such as monitoring behavior, developing patches, fixing bugs, or scaling the application. This cross-functional team with expertise. So once again, it kind of shows like you don't need a huge team to pull these things off. We certainly didn't have a huge team to pull these things off. It's like 3 people can build a DevSecOps mesh-based cloud in 3 months with a good research crew, and we have a very good research crew. So you put it together, and then from there on, then you just have this thing that you can just. It shows right here. It's like easy to fix bugs. It's easy to develop ways to patch. It's easy to monitor the behavior of it, right? And we haven't even implemented all of the code that we've built for it. We're just kind of phasing out the order of the implementation of our policy as code, right? So anyways, seamless evolution from DevOps to DevSecOps. We don't have that challenge. One thing I do have a situation around me where I have to say this in a way that won't sound like I'm like breaching someone's NDA or something. I work with a lot of companies, so it's not, just so that all of you know, whatever I'm saying might not apply to the company that you're thinking of, because I work with a lot. So that's the way that I'm going to not get in saying the wrong things. But there are some in my research space that have this challenge right here where they sit in more of a DevOps posture and are moving to more of a DevSecOps posture. And I have entities who operate in a pure DevSecOps posture. And I'll say the development rate of the entities I work with who are in the DevOps posture develop much slower than those in a DevSecOps posture, but the technology and the backbone and the spine of it all is very different too. So it's not just the team, it's the infrastructure as well. So just because someone has DevOps doesn't mean they can just start operating in a DevSecOps capacity. It's not really that cut and dry. It might take a year or something to migrate out of a system, because you have to go and figure out, like, okay, what are your DevOps policies? Like, what's all this stuff? So, you know, like, what's your pipeline look like? And then how are we going to basically make it a little more lighter weight, I guess, or more modular is maybe a way to think about it. So anyways, this kind of talks about that process. I'm sure I'll have more thoughts about this as I kind of work with some of these entities. This makes a good point here. In a DevSecOps platform, security assurance is provided through built-in design features. This is huge. Built-in design features. So it's like security by design, right? Secure by design, such as zero trust. Zero trust. Why is it that we're launching our cloud not only in a VPN tunnel, but then our front-end facing website then also sends you into different load balance tunnels? None of them even have access to each other. So just getting into our network, you get dropped into a zero trust LAN, and then you get multi-factors to another zero trust LAN within that ecosystem. And by having design choices like this, also if we have certain situations that we need to mitigate, it's much easier to mitigate a situation when you already have, say, like zero trust in your design, where you just have like, you can have just like, I have like a kill switch. You just like pull out one little thing and it lets me maintain all of my access, but it'll put out access for, say, like someone doing something potentially malicious or complicated. We have like some crazy stuff, but it's all zero trust based, right? So even in our location, we have a minimum of 2 unique LANs, a minimum. I'm not going to say just how many LANs. We have a lot of LANs. And then we're already going to be implementing our network over 4 unique LANs with a minimum of like 3 unique VX LANs. Zero trust design is a good way to structure multi-factors. And you can also have multi-factor tunnels where someone has to, say, have a authentication password that then has, say, like a MAC address validation process where the MAC address has to then match something, where then there's, and you can, and then you can like automate down from there and then make it to where it also has to like show their face somewhere in there. I mean, you can do some stuff to like really make it crazy. But anyways, like security up front, even if sometimes it's annoying, like forcing people to use a tunnel whether they like it or not, don't make a tunnel an option. Force it as a choice. That's security. Is forcing the doors to be locked as soon as they close. It's like if you go into a high defense building where they have like the little security doors and things like that, and you like swipe the security door and you go into the door, ideally the better ones automatically try to close too and won't just stay propped open, and if it is propped open they'll beep at you. And I'm sure if anyone's gone to security doors, you know what I'm talking about. And then as soon as you go through that door, it locks itself again. Using a VPN, I always kind of see it like that. I see it as like a similar to a skyscraper or like a building's physical doors at the entryway of the building or the business center. That's kind of how I always see those tunnels. Anyways, let's see. DevSecOps platform. Security assurance is provided during the runtime operations. Okay, so this is something that I use too, that I would recommend using. But so open source AI can be a nightmare to manage. So if you're using AI, either know what you're doing or don't use open source AI resources. Let me just throw that out there. Unless you just have a lot of time to learn or just really love it or something, I don't know. But AI, like if you... Anyways, let me just read this. So security assurance is also provided during runtime operations phase by continuous behavior detection prevention tools that use sophisticated techniques such as AI and machine learning. As you start working with certain platforms, I will say that manually building machine learning and AI generally requires a maturity process that needs to be understood. And if you're working with open source AI or machine learning, you get no, like you have to let it all mature. It's complicated. Otherwise, if it's a closed source format, then it depends on how good that engine you're using is or paying for is. Maybe read reviews or something like that, or see if it fits your use case. Because pre-built AI resources also have pre-built context and pre-built maturity. And having pre-built maturity sometimes is worth the money depending on the use case. So I'm not going to like throw out recommendations because I don't want people to think like there's one end-all be-all that's better than this thing for a resource. But what I will say is, think about your use case. Your use case is going to be the most important. Now, I had a thought about AI earlier in this document, so maybe I comment on 573 because they mention AI here, but not in one of the other areas. So, line 573. Okay, so DevSecOps platform. It is a really good document. This is really in depth. NIST does a good job with stuff. This is beefy, chunky stuff. So let's see, AI, machine learning, DevSecOps pipelines, workflows. Anytime you can code workflows, forcing people to use a VPN file to access your cloud is a forced workflow. If anyone wonders why do I require certain things, I'm forcing workflows upon you. Now, those workflows will get more automated as our team gets more sophisticated. But at the level of advancement that we have, if we're trying to get projects off the ground quickly, DevSecOps, agility, let that agility be king, then we have to focus on like forcing that workflow to be secure, right? security assurance. So another distinguishing characteristic is that the, here we go. Now, security tools. SAST tools. This is an interesting one to talk about, and DAST tools. You can integrate these with IDEs. Let me just show you. We built one. So what this means is, like, if you have a tool that has, say, certain resources like payload testing and delivery, and I should probably look up DAST versus SAST. I always forget these real quick, but let me just pull up. So let's take a look here. So DAST versus SAST. We built a tool that matches, I think, SAST. Let's see. Oh, depending on how you build it, it builds too. So let me show you another resource that we built out that is based on this concept of having SAST resources built into your workflows. The very, 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 very first thing that we built into this whole thing in our white paper was a SAST tool that I built myself, just because you don't have to use someone else's tools. You can build your own. You don't have to use a pre-made SAST tool. You can make your own. So the thing that we use to deploy all of the resources in our minimum viable product for the Olympiad was the Athena Zero, which is a payload delivery tool and a SAST tool. It is an agnostic cloud brute forcer, and it specifically has a number of tools in here, including Nmap, SQL Map, OWASP, Zap, Metasploit framework for building payloads to be delivered. And then if you look in the Olympiad dev document, there's a section where if you look in our code and what's going on in here, if you pay enough attention in here, when I was trying to figure out the fastest way to get this thing to automatically build itself, I actually built it to attack itself in a similar way that malware attacks are deployed. And so, but instead of building malware, it builds the Olympiad. So instead of like deploying ransomware, it deploys all of the tool suite, which, if it works, it works. It's fast, it's efficient. We have more efficient ways to do it even better than this now, so that it's not just like us like strong-arming our resources into a resource. That's kind of what this is doing, like sort of a really harsh way. But if you're doing cloud native development, whatever works because you can modify your code and update it anytime you want, as long as it just exists first. Make it exist. You can reshape it anytime you want. And right now I'm in the middle of a rework, and the rework alone is so much faster than just like the initial days of getting this code going, because we already have all these resources built out. But the purpose of, say, a SAST tool kind of goes into, let me just go read what this is. I'll just drop this link in the chat, because why not? Oh, Randall already did. Thanks, Randall. You can read this, but like white box security testing means that, well, just, yeah, you have an idea of what's going on in the environment that you're working with, versus black box security testing. You don't have an idea of what's going on in the environment you're building, and it's kind of how the way that I see it is like going in blind versus going in knowing everything about an environment. If you're building your own environment, then that's, SAST tools are great. That's why I built one of these as the first thing that we used. And then this just shows that you can find vulnerabilities and so on and so forth, because why not? So let's go back to the document. So these tools are tightly integrated, right? And with IDEs and resources like that. So I have this tool and resource accessible right here. Like, it's just boom. I can just pull it up without having to spend a lot of time. Oh, did it time out? No, it didn't time out. And I just have Nmap and whatever tools or resources I want, just like right here, for me to just like start like catapulting code around to whatever that I want. Now, there are probably more graceful ways to do this. This is just the way that my brain is like, oh, I know how to do this. I'll just do it this way because I'm familiar with it and it's fast. You don't have to build your own custom tools. You can use someone else's, once again. It kind of just comes down to what you're comfortable with, what you're familiar with. I'm sure there are tons of SAST and DAST tools living in here as well. So just because I've done something one way should never mean, especially in this general space, that everyone should do things the way that I do. And that's what I believe. But this is a good delineation here of, what's DevOps versus DevSecOps. DevSec or DevOps tools, they perform analysis such as identifying vulnerabilities and bugs through efficient scanning in the background. So it's just different. It's just different. This has a little summary. So in summary, security testing and robust incorporation of security controls are integral to all pipelines instead of being regulated or relegated to separate task or phase. What this means is that DevOps security is separate, and then once again, like DevSecOps security is woven into the workflows, right? The DevSecOps platform operates during runtime in production, providing real-time assurance of security through correction mechanisms and enabling certification of continuous authority to operate. And so we want to just remain like keep your technologies continuous, right? That's the idea. And going back to the idea of let's see, pulling up this right here. So a thing about why Pi-hole is an initial security thing is you can automate blacklisting. You can set up regular expression filters, and you can basically start to automate things that'll block traffic. You can do port blocking. You can basically use Pi-hole as just a generic security assurance layer as you're just like getting your project off the ground. You can mix it with other tools like this, whatever tool that you want to mix it with. But we chose resources that contribute to real-time assurance with mechanisms, right? So providing real-time assurance of security through correction mechanisms. Stuff that happens whether I'm physically touching it or not, right? Like whether I'm like holding on to it and typing or like I'm sleeping. Like while I'm sleeping, I want security to happen in my sleep. I don't want to have to 100% of the time have to get up and do something about it unless it failed, and then I can go do something about it. So DevSecOps is the idea that you code things that help you and automate your attempts to be secure. Let's see, key primitive tasks, key primitives. So let's see, more tasks that are key to DevSecOps. Concept of CI/CD. This gets pretty in depth. So let's see, building blocks for CI/CD pipeline, designing and executing the pipeline, strategies for automation. This is all stuff we've been talking about. Requirements for automation tools in the pipeline. Concept of pipelines and CI/CD. So the Olympiad is designed for building CI/CD pipelines very specifically. I think we're getting to the section where this actually shows a lot of the stuff. Oh, it does. Okay, yeah. So this kind of gets into like a little more specific to like what is it that we build. We specifically build like pipeline architectures and open source templates for pipeline architectures. So if you're trying to learn how to build supply chains or pipeline architectures, or supply chains or pipeline architectures, then that's what we do. If you're trying to do other things, like while we know a lot of other things and might do a lot of other things, we might not particularly specialize in other arenas. So this kind of gets into a little more of what we live and swim in 24/7. So unique concepts, workflow. Let me just kind of skip through this a little bit because I've kind of gone through some of these things already. Build, secure, deliver, test, secure, deploy. So outlining these bullets, depending on this later stage, CI/CD can involve the following tasks. So when we're talking about like what tasks are involved with continuous integration and delivery or deployment, then that involves building something, testing the thing you built, securing the thing that you built, and then delivering the thing that you built. Now, this kind of goes back to, I'm going to use the dojo as a recent case study because we spent time going through this process directly, and we actually did the delivery process for like our first sort of, it's like an alpha delivery last night of just like opening general access so people can access our test environments. But the first thing we did was we built a cloud together as a group, and then I talked about all the concepts around the cloud, how you would monetize that kind of cloud in the dojo. And then we had a tournament, and that tournament was designed to test our infrastructure, and that video is actually on YouTube. So our test for this was live somewhere. Let's go over to my channel, I guess. And if I go over to this and I say, I don't know. Oops, I don't want to do that. Cancel that. Copy link address. So let me just paste that in the chat. So this video in particular was our test. So that's something you can check out just to see what it looks like. But the relevance of it was less about whether or not it made good content and more about, I need this thing to work, and I need to know for sure that it's going to work, and I need to know that it'll be global because it needs to be a global piece of infrastructure, and it needs to be continuous in its operation. So then we spent some time securing it, so that turned into a number of delays for us, which you got a delay for security, so be it, because security, gotta have it. And then finally, you can start to deliver, say, like access to your resource or access to your application environment, whatever you've built, whatever you're doing. And so that's continuous integration and delivery. So now that we've got, say, like user access configured in our cloud, then the next step for us is, let's say that we build new applications. Then right now we are in the process of testing our VPS infrastructure. So our VPS infrastructure was built from this. Once again, we build everything from this. So our test infrastructure is built from this hardened cloud environment. So this is just a hardened cloud. That's all this is. And then now that we have that built, then we need to test out the hardened cloud and then hand out access to this. This is kind of like giving someone access to like a private AWS sort of thing. Almost is kind of a way you could think about it, but it's more specific to being used as a code pipeline rather than, say, hosting a website per se. So it's kind of more, there's a diagram that will kind of show more specifically. But anyways, we are in the testing and securing phase with our VPS applications that we're building and distributing out to everyone. And then ultimately, we will be able to then deliver the application that will then allow folks to be able to use that. Right now, we are delivering Minecraft. I showed Minecraft, so you know what I'm talking about. So that is an example. So then this is another example here: build, test, secure, deliver, and deploy. So if we take a look at the structure of what it looks like when we're working through all of this, the workflow process does, I mean, it just looks like this. Basically, you know, we commit some code, and then we integrate that code into our environment, test it, and then if we have to just continually like test this before it moves on to delivery, then we just, you know, do what we need to do. And then once we've gone through testing, then we deploy into a test environment, which we have isolated unique environments, all kinds of things. And then finally, once we get like a clean test, we oftentimes will delay if we don't quite get like good acceptance tests. And so whenever you see us delaying things in the dojo at this point, like this is what's going on. We're going through our continuous integration and delivery process. And then let's say that we get to a point where, oh, we just did a continuous delivery process. Our continuous delivery process stops here before we put it on our bare metal. And we're like, okay, so that we've made some updates here. And if we need to continue to modify whatever we're integrating into this, then I have to bounce back up into continuous integrations to commit more code, modify code, adjust the code, do whatever we need to do with it. Then to finally deploy into a production environment, which this would be our first test of the production environment. And then Minecraft, notice that I make it to where that environment ideally has zero trust from this environment. So you can't even see our Minecraft node hiding in here. So things like that. So, anyways, we are in a process right now. We're going through a number of acceptance tests for our virtual private servers. So all of this is stuff that I would say is pretty. Yeah, I agree with this general flow. So let's see what we've got going on here. Let's see. The unit integration test show diagram. So CI/CD. So this kind of gets into it a little further. I think this does a pretty decent job sort of like outlining it, so I don't know if I have too many notes on this. I've kind of read through a lot of this, and depending on how tired I get, I'll go as far as I can get commenting publicly, and then I might have to do some finishing of things. So anyways, let's see. So continuous deployment. I'll be right back again. 1 second. Here we go. I might randomly have to just like step away for brief moments. Like randomly start having things going on with me. It's fine. Anyways, so we're going to go ahead and continue here. So let's see, continuous development. Let's talk about how this works. This is actually, this is probably a pretty educational section. One of these days I'll spend some time like maybe doing a cover for beginners for this sort of thing. I don't really know how you would teach this to beginners because this is, I don't know. There's probably a way to teach it to beginners. If someone can help me figure out how to teach this stuff to beginners, we can try to come up with a way to make these concepts consumable. I have no idea how to make these concepts consumable. So anyways, continuous integration, that has to do with just like maintaining your pipeline. That's kind of how I see it anyways. I guess this last sentence says like the process avoids the integration challenges that could happen when waiting for release day to merge changes to like into say like a release branch. Continuous delivery, I kind of think of continuous delivery as more like what are some good comparisons if I can think about this? Maybe this is like something I can comment on. And here's think about like what would be some good comparisons. Let me make some notes to myself, and I'll revisit this like at a later time when I'm not live. But I think I want to revisit lines 626 to let's see, view lines 626 to 646. 646. So I need to review line 626 to 646 for providing commenting with examples of continuous items being defined. So one thing that I will say about this section up here when we get into legal documents like this, and technically it's not a legal document, but because it's a government document, technically like it has legal association to it. So one thing that is important when we're talking about the context of language in documents like this is that when you see something that produces a definition like this, then you could consider this a otherwise legal definition, which then you may produce, say, like trainings or otherwise insights out of. And what an insight actually is an interpretation of how you read this from your perspective. Now, the difference between, say, like certain professional entities is if you're not a trusted professional entity of sorts, whether it could be that you don't have a doctorate or maybe you don't have a law degree or something like that, or you don't have like certain like tenured skills or something like that. To develop certain types of like tenured engineering skills, you have to work with something for about 6 years, and then you can qualify what are called tenured skills. You can learn how to do that if you really wanted to get like into it. You can technically do that as an alternative to college to get certain credentials that you can otherwise only get through college, for example, because of how that works. I don't want to get too much in the weeds with that more than the fact that this as a legal definition holds weight. And the way that you interpret this also holds weight. So if you do something based on your interpretation of this and someone else interpreted it differently, in theory, in the context of how these are structured, you would both actually be correct. That gets complicated too, because then there's conditions around that of which what else would qualify that correctness. And so that, that gets, well, this is why at that point, this is when people start hiring lawyers and things like that to like differentiate certain things to kind of get validation around which interpretation holds a higher weight, I guess. If you ever work in the audit space, you'll deal with this quite a bit, where you have to go talk to, say, like certified audit bodies, where you'll have to come up with an interpretation of what you think XYZ means, and then you have to build a process from your interpretation of what this means, and then you have to then go take that and hand it to a certified audit body. And then upon handing that interpretation to a certified audit body, if they then validate whatever that is, then that validation creates what would then qualify as market correctness. If anyone wonders, like, where does that come from for, like, this is the way that this architecture is supposed to work, or like the legal stamp or crest for how that's designed, it gets complicated. So I went to school for a number of things. One of them was like business law. So this is related to business law. NIST is associated with business law and legal things. So if you ever study legal to some capacity, you have to kind of deal with learning how some of these things work. If you do forensics, you depending on what kinds of forensics you do, you will have to deal with the concept of interpretation and evidence and producing a valid or appropriate evidence. I don't know. So anyways, I did want to talk about that too, because the other value of knowing that is if you're trying to say that this is what you believe, this definition to believe, as long as it's your interpretation of what this says, then you can actually say that like someone can't necessarily say that you're wrong, because you get a lot of people in the industry who didn't go through, say, like an audit body process, and then will call other people's interpretations wrong, and it's not that simple. It's never that simple. So anyways, this is a great way to baseline definitions, though. So if you're trying to like write a blog for highest likelihood of correctness, then have that blog cite from legal definitions rather than, say, like other blogs. So like if you're writing a blog about continuous deployment and a blog about continuous delivery, the weight of the value of what you are interpreting is higher if you write it from legally categorized documents that are actively used for business. And let me emphasize actively used for business, because what this means is that more than whether or not it's right, that's what companies look at as the perceived rightness, which then they pay for and fund and monetize. So if you're trying to build a monetizable structure, then this would be, say, a definition that someone in the market of monetizing cloud would be able to agree with, because it's in agreement with their monetizable structures. And if it's not structured in this way, they themselves might not even be able to, say, monetize the cloud. If they have, say, regulations to have continuous deployment, and then they're like, well, I didn't, I based it on a blog rather than basing it on, say, like this, then they can be like, oh, then you did it wrong. But if they're like, well, I based it on this and this was my interpretation, you might have the same answer, but if you're saying, like, what's the citation or the source that you got the language from or the interpretation from, it changes what will get approved and what will get denied. And that's why legal documentation matters, and that's why NIST matters, because, yes, things like that. It's complicated. So if we're looking at, say, continuous integration versus continuous integration, continuous delivery, and continuous deployment, this would be like if you're building updates. Maybe this is where I make my notes. If you're building updates for something, then that would be like a continuous integration task, like adding features, adding things that you might be doing. And then alternatively, if you are building like continuous delivery pipelines versus continuous deployment pipelines, then the difference between delivery is like delivery has to be like handed to someone, sort of an idea, versus deployment is something that's just like executed. So like automated updates, that would be like continuous deployment, versus manual updates, that would be more like continuous delivery. So like if someone wants to get access to our like current environment, then we currently use a continuous delivery system for producing delivery for reasons. But anyways, that's just like the definition and structure behind how that kind of works. So I think that's a pretty good one. I feel like coming up with examples, if I can think of something other than like updates or something, I don't know. Maybe that is a good example. I don't know, but I'll have to come up with some comments on that because that's gets me thinking. Let's see, building blocks. Yes, for a pipeline. Let's just scroll through this. This just kind of tells you like the different items that you can use for a continuous pipeline. So it kind of just shows like some specific softwares in here as well. So it'll say some of the tools. I'll give you an example like GitLab, Jenkins. I'm a fan of GitLab. I don't know. So I would always say GitLab's a great tool. Kubernetes is a great platform in general. That's one that we use as well. But this just gives you general makeups and configurations. Kubernetes has built-in APIs, things like that. There are different types of ways to automate these things. So that's something that you can read. That I don't think I have any specific comments on. Let's see, good comment. Integration in terms of DevOps is adding to a repo or creating or updating a version. Delivery is like taking that integration to production repo or updating production versions with those integrations. That makes sense, yeah. So that's a comment in from Randall. So thank you for dropping that in there. So we're talking all on the topic of these things, you know, DevOps, DevSecOps, pipelines. What's the difference between these things? So let's see. Executing pipelines. So if you're trying to design and execute a pipeline, there's pretty much no wrong way to do it outside of just you pay attention to what your use case is and choose something that will work with your use case. You can use GitHub, GitLab to build source code and technologies. One thing that you can also do is you can have, say, like a, let's see, I'll just pull it up over here. So like if you go to GitLab in here, and let's say that you want to use GitLab Community Edition, which is free, you can just use it anytime. Instead of using GitLab's hosted version of whatever they use, you can set up, say, like a free private repository with this, because every Docker account gets like one free private repository, and then toss GitLab in that repository, and then like just host it as like a Docker container that you just have like routinely backing itself up to Docker Hub, like in a repository, like a private repository of your own. And that would be basically like a low cost to free way of having a hosted GitLab where it doesn't live quite on the web either. It lives in Docker Hub, and then at the same time it lives like in your Docker environment. That's like a low cost, secure way to get a GitLab pipeline running for anyone on a budget who just wants to start a project today at no cost. Because Docker is a free application. Now, more specifically, how can you strap that? Let me just show you a quick, neat application for doing these things. So Docker Desktop uses emulation, which means that it produces like max compatibility, making it very what you could consider like agnostic for quick tests or like getting a quick project off the ground. So if you did want to use just like your own private hosted, self-hosted Docker or GitLab that lives specifically in a Docker desktop, you can do it that way, and then you can just run it as an app that you made. You can make a little GitLab app. It's kind of neat. Anyways, if anyone, I don't know how many people actually do that, but it's like I like doing that. It's pretty neat. I'll stop saying that and we'll just continue on. So setting up the source code repository, there's one way to do it. I just showed you. I'm not going to show you like the beginner like step-by-step version of that, but Docker desktop, put GitLab in Docker desktop. Use Docker desktop like a server application environment. Build process. I like building Kubernetes applications with Docker. There are a lot of ways to do that. Let's see, configure and execute the build process. Talks about automation. Now, in my build process, if you don't like doing everything through the like Docker commands, this is just Portainer, and Portainer makes for a neat way to just like build things. So notice that I have this little build process sample right here where I built out a series of sample SAST tools that were all designed to attack each other, and then you can also visualize those attacks. If I can pull that thing up again, which is what this thing was showing when I was showing like those little spikes right there is like the little activity from the things. You can see the unique ones as they're doing things. We see you know, some activity from Athena 5 to Athena 8 right there, so on and so forth. And so, you know, you can get some direct metrics and some direct data from this stuff. Anyways, that kind of samples like this idea of, you know, what's your build process, right? You want to know what that is. And then like, how do you secure your process? We do a lot of our testing with just like constant pen testing. I don't know if that's how other people like doing things, but we just like constantly hack our stuff and as best as we can, and then come up with a hack we haven't come up with yet. And also it's just like one of my hobbies. I like hacking things. But it's our infrastructure, so it's pen testing our infrastructure to make sure that it's safe. So we use a series of tools as well. And then ultimately I have some other DAST tools that I use. We have a lot of tools, but we constantly use these tools and are constantly looking at our security and have like automated alarming, automated alerting. You gotta do it. And then while you have all these automated processes, then you know, create a deployment environment. So then you need to create a delivery pipeline. So we just finished building a delivery pipeline. The deployment environment, we built that. That was this sample right here. Then our pipeline, we just finished our pipeline. And then let's see, test the code. We're in the process of doing our code testing right now. And the first sample of that was that YouTube video that I linked. Testing our pipeline. So, you know, this is pretty spot on with like the process that we follow anyways too. I mean, a lot of this stuff is built off of like the same communities that everyone is building all these like, the Kubernetes community is so lively if you talk to folks and just see what they're doing and look at their projects and stuff. It's pretty neat. So it's really cool to see a lot of this stuff come together and be living here, because it's like the stuff that we live. And it's kind of also fun when you work on something before it even pops up in these documents. It's kind of neat. So anyways, and once again, millions of people have been doing this. But by the time things hit NIST, it's already been done. It's that like, it doesn't make us like the inventors of these concepts. I don't want anyone to think that I'm saying that I fabricated all these ideas all by myself with my own one head. Nope, never. That's not possible. So let's see, to reiterate, the primary stages of the CI/CD process are built. Let's see. This is so much documentation. It's good though. So let's see, when an update is made to resource service, build tool. Yeah, I don't know. This is all stuff that makes sense to me. So what I will kind of swoop down to is these blue parts are what the Olympiad does. So if anyone's like, okay, so where in this diagram, like, if is there a diagram of like what the project that I've been working on is? The project I've been working on is a code build or code pipeline, basically both rather, for how that works. And so I use Docker Desktop for code build, and then you can use Kubernetes too, but Docker Desktop has QEMU in it, which is an emulator, and I like emulation, and it makes it nice and agnostic, and you can put Kubernetes right inside of it. And so I love it as a good management layer. I think it's great, in my opinion. I think there are other great options that are just as good, but this is the one that I use because I can't do everything at the same time. So then from there, let's see, where's the Olympiad dev here is basically what we use for the deployment and delivery processes, and basically like the other part. So let's see, let me go back to that diagram. So the Olympiad repository basically contains the code build pipe, or the code pipeline. There we go. So the code pipeline lives up here. This is the Olympiad. This is inside the Olympiad. So that this right here has this inside of it. And that is this blue where it says code pipeline. That's what that is. And then code build, that would be what I use for that oftentimes is then tossing the Olympiad into Docker Desktop on an instance. So that would be like on your laptop or your desktop or whatever your end user device is. I like to use Docker Desktop to interface with the pipeline. That's what I'm trying to say. Yeah. So anyways, this is something anyone can build. It's all open source, and it's also, you can reverse engineer what I have, do whatever you want with it. It's just it's a coding template, and a template is a template. A template is always meant to be changed. Templates, if you leave a template the same, I mean, people use stock photos, I guess, but it's like, if you're taking a stock photo and just posting a stock photo, you can usually make it more unique by maybe at least adding some copy to it or something, or some language, and then at least you then have a meme, right? So templates are meant to be changed and modified and used in the way that's going to be best for your use case, which is going to be probably different from whatever my use cases are, or the same. It just really depends on what your business is. You know, we do manufacturing and code development and like firmware development and stuff like that. So we are working on things like firmware resources for the kits that we build. We manufacture these things. And these are also code build devices. So instead of Docker Desktop and this would be the same thing, to be honest. So just using Docker Desktop for free, or getting, say, this, you can accomplish the same general goal. This is what makes me a terrible salesperson, probably, is that while you could buy this from me and I could make money off of it, you could also pay nothing and use Docker Desktop. Do I think these things are great? Yes. Do I use them? Yeah. Do I travel with them? Whatever, I do. But it's also because I'm biased because we made them, and if I made something, I think it's cool, so I'm going to use my stuff. But anyways, then from there, for people who don't want to pay for things, then you don't have to. As a matter of fact, you could build a living just by downloading Docker Desktop and then getting a code pipeline in whatever format you feel like getting. That doesn't have to be ours. It could be anyone's. It could be an AWS, just like this diagram right here. You could have Docker Desktop and AWS and have this exact same diagram all on your own, wherever you want it. That's the joy of agnostic, right? Agnostic means that Just because I use something doesn't mean that you have to use the same thing to accomplish even the same goal. We can accomplish the exact same goals with whatever we want, whatever hardware, be laptop servers, and that's the joy of cloud native versus like prim or conventional cloud. You can make hybrid cloud with it. Hybrid cloud means that you're using more than just, say, AWS, or more than just Azure, or more than just a local on-prem cloud. That's called hybrid cloud, right? So anyways, going through more of this code building code. So strategies for automation. This is good stuff. So if we are comparing to DevOps uses a forward process with a delivery pipeline. So you can kind of read through some of this. So automation results in following benefits. So generation of data regarding software static and runtime flows, reduction of development and deployment times, and better utilization of the team's expertise by assigning routine tasks to the tools. So I guess one thing we could also say unanimously is if we're automating things, you're reducing overhead, and overhead can be defined as time that could be better invested elsewhere, tasks that could be automated and taken off of you, things that waste time, because wasting time wastes money in business, because for the most part, like if you're paying a whole bunch of people 6 figures a year to build this stuff, every second that they're doing anything, that's basically just like a pile of money just being like set on fire. And if you're not making money faster than the burn rate of your capital, then that's when people just go out of business. And for the developers, it's usually not as big of a deal, because worst case scenario, they just get laid off while you're just like going bankrupt or going out of business or something like that, and everything ends. And when you work in like cybersecurity, you deal with like people having like cash flow bleed outs and things like that, because your goal is to protect the business from the thing that causes it to fail, which is usually losing all of its money. And oftentimes the source of that brings into the things that make cybersecurity jobs exist. So so automation helps with a lot of these things. It helps with a lot of overhead. It helps with not having misconfigurations. It saves a significant amount of time, and thus saves a significant amount of money. That's, I think, I don't know, they say it just fine in their fancy ways. So choice of activities. I specialize in compliances, so I come from like the regulatory space, and so I got like certified in PCI and HIPAA. Those certs are probably expired by now, but either way, that's what I used to do, is like build code for regulations and SOX, and build compliance modules, if that sounds exciting. So I used to help build compliance modules for Sarbanes-Oxley, HIPAA, and PCI. Well, why is it amazing to automate this stuff? These things are so specific and so precise that you're probably just going to fail these regulations. And if you don't automate your compliance, you're just going to get all these compliance fines from like human error. It's like inevitable. Like I guess that's probably how I got into this space, if I think about it, because I used to do work for helping people with like hospital, like PII, protecting HIPAA, personal identifiable information, stuff like that. Anyways, tasks that are repetitive. So when you have really mundane tasks, it also increases the likelihood of having high turnover in roles where they have to do a lot of mundane tasks. And so you can also reduce turnover by working on automating mundane tasks as well, which also increases creative output at a company, because there's this myth that you can automate people out of jobs. The reality is that without automating the jobs, people just end up working until they have no life. Or if you automate things, then tell them that they don't have to work all the time. Then what happens is people start to unlock creative potentials when they get sleep. And it only happens when people get sleep. So if you're working at a company and you find that you're working 80 hours a week, if you shave that down to 30 hours a week, you'll find that you'll suddenly have a lot more capacity for thinking about things. But more importantly, if you're the manager of someone who's working 80 hours a week and you want their output to increase, think about the impact to the person that you have working 80-hour work weeks if you're managing someone. So if you're managing someone and you want their output to increase, then automate things that are mundane, because things that are mundane cause morale and motivation to dwindle and things like that. And they only really work out for a season if there's a way to get that task to go away. But alas, there are some jobs that you can't really just automate things in, and it's not always that cut and dry and not that simple. In an ideal universe, everything would be perfect, so it doesn't really matter. So testing the modules for that time sequence operations. Yeah. Boring things. Automate the boring stuff. Maybe that's the best way for me to put this. Testing workflows. Chaos engineering is the idea a little bit around automating your testing workflows for like chaos engineering. You want to automate it. Testing the services that are resource intensive and like to constrict operations. Once again, anything that reduces overhead and increases time and availability for your people and your team, the more you can increase time and availability for people, generally things just work better. So choosing candidates for automation based on criteria above. So it's interesting that they talk about compliance first, because that's what I spent the most time automating, was definitely compliance stuff. The market for compliance automation is so thick just because like lowest cost to compliance almost always wins, and sometimes cutting corners puts people in a situation where they thought they were going to be lowest cost to compliance, but then what they'll do is they'll try to meet compliance with 100% open source resources, and then maybe open source resources, sometimes if not used strategically, can increase labor costs if you're not building, say, like a direction for where their development efforts are going into, like, say, like a code repository where all of their work ends up in one place. So I don't know, it gets complicated. So you have to, open source, if not done right, can be more expensive, and then non-open source, if not done right, can be more expensive. So it just really depends on the companies and the use cases and what they're trying to do in a it's all a conversation. It's all negotiation. So after choosing the candidates for automation, let's just kind of keep going. This is all just fine. So let's see. So 3.3.5, requirements for automation tools in the CI/CD pipeline. So the main utility for performance, so easy integration. So one thing you want to do is, if your integrations into your CI/CD pipeline are not easy, then it is probably worth taking time to either develop or chisel out tools that are going to, what I guess you could call, enable integration to become easy. And so enablement tools are a thing, and what would I describe an enablement tool as? Like, let's say that you're trying to integrate something into a developer's pipeline that's a little tricky to develop. And so this I feel like is one of the reasons why like edge computing exists. So let's say that you want to have the new Microsoft Cloud gaming platform in Azure, whatever, like that Xbox streaming service. It uses a degree of something called like edge computing. And what this does is it lets you then like play your games remotely with like less latency and stuff like that, as if you're like playing the game on your actual machine. And so without edge computing though, you then potentially have a situation where if you're trying to stream a game over a cloud stream or something like that, like Netflix, like before some of these other platforms created more edge computing came into the market recently more robustly. What edge computing did was made it easier to integrate gaming experiences over the cloud, if that makes sense. I don't know if that example makes sense, but it's a real example, so I don't know. So the idea is that if there's something that people might like playing video games Netflix style, where they can just like go to a web browser and then like play a video game and it's just as smooth as like watching something, that used to not be an easy thing to do. And so then we just didn't see it. We didn't, 2016, you're not like sitting there streaming Halo from Microsoft's Xbox gaming cloud. It wasn't a thing. So that you want to then edge computing. So so we focus on edge computing because edge computing allows you to unify multiple locations. So for us, sort of like a unifying thing that we ended up using edge computing for was, what if we wanted to have data centers, but we didn't have, say, like a dedicated single location with maybe like the kind of pipeline you have at a data center, like the kind of hosting, like a 10 gigabyte fiber pipe, all this crazy stuff. What if we didn't have all that, but wanted to get the benefits that you might have with that sort of cloud environment? What we ended up doing was using the principles of like edge computing, kind of how, once again, edge computing has made other things possible, like cloud gaming. But for us, edge computing has made it possible for a data center to live in multiple locations all at the same time and function as if they all live in one prim location. And we run our DevSecOps service mesh that way, where our design lets us basically extend bare metal to different locations so that it's suddenly easier to integrate technology into our cloud, because if you get a fragment of our cloud, the way that we've engineered it, suddenly that cloud now also physically acts as if it lives in your location, as if the whole data center is now in your office, and all you have to do is just like tap in with a little infrastructure, and then boom, you're in. And so like our DevSecOps dojo members are in the middle of experiencing this, where we're teaching like how do you scale things out that way? How does that kind of scaling work? To where you make something that would be very difficult to integrate, where it's like you can't really have, say, like a scattered data center that works well without doing certain things. But then by tossing in certain things, then we enable like easy integration and easy access and things like that. So requirements for automation tools to work, basically these principles need to make sense. So kind of reading through this a little further, basically enables a class of tools to be an integral part of the DevSecOps process rather than one managed by a central platform engineering or site reliability engineering team that could become hamper deployments. So I think that's a typo. So I guess I'll comment on that typo. I'm sure someone else will find it too, but typo line 774. And that was become hamper. Okay, so that's a typo. And then, so the idea is, let's say that, because we're about to have 4 physical locations, right? And instead of having, say, one central platform, if our one location were to go down, once we have our platforms all offline, then as long as like over 51% of our physical locations are alive, it doesn't matter. And everything continues to stay online and run online as if nothing ever went down in the first place, and everything will feel and work as if it's just been working and there have been no problems. And this is once again thanks to edge computing being integrated into the use case of a cloud native based DevSecOps mesh, right? And so then what that does is it distributes your cloud where you have built-in high availability, so that if it also then broadens your bandwidth pipeline, where then your hosting is then distributed across locations as well, where then every location that has, say, like a new parallel connection pipeline, and you have another one that has a parallel connection pipeline, maybe like a 1 gigabyte or even a 500 megabyte per second internet connection that's being used on that connection, then you can just basically add pipeline to your cloud by adding physical locations, and then every physical location you can then add more nodes, and then if one goes down, then everything stays up as long as most of the locations continue to be online. So it's resilient against outages. So the problem with consumer-based hosting and hosting on a consumer line versus a data center is you have a higher likelihood of your network having outages on consumer lines. And so by us having a minimum of 3 physical locations, it mitigates the risk that comes with hosting from home. So when people be like, oh, but you can't host from home, that's not very stable. Well, it's stable if you host where your cloud lives as one cloud in at least 3 different locations, and then 51+% of that stays online at all times. And then if it goes down ever in one location and the rest of it stays up, then no one ever notices, and it continues running just as resilient, if not more resilient, than, say, running from like a central, very powerful pipeline from, say, like a data center. And then it's also distributed across different locations. And then on top of that, if we have people who want to connect into our environment, then they can once again use edge computing to then scale out to their location if they want it to feel a lot snappier and have like that more readily available data in their network. So you can do so many things with this. It's pretty cool. So anyways, an accessible interface that can be used, I guess I'm reading the next bullet, an accessible interface that can be used by all participants involved in the software release workflow. Have analysis. Let's see, insightful. Yeah, okay. Coverage for wide variety. Backend infrastructure. Now, this is another one right here that we specifically use. I guess all of this is kind of the same thing. So I guess all of this is part of our pipeline, because, yeah, accessible interface that can be used by all participants. I mean, that's even seen in that YouTube video. That's the same thing that I've been showing with this right here is accessible to everyone as long as I make it available to them. That's more of like an authentication thing. So once I give people their access, then yeah, that's gotta be built in. So that's right there. So we have the second bullet right here. But this third bullet is interesting because let's say that I get to the point where I want to bring in more users, but I'm not so sure that we have the scalable infrastructure for that. I could create, say, like an emergency scaler that, should we not have enough infrastructure and we suddenly get too many customers, if I plan ahead of time for that, then let's say we get too many customers coming into our environment, but we were ready for it, then we can scale out to Azure, which then suddenly we incur their cloud costs. But at that point, we're probably making so much money off of whatever it is we're selling that we can suffer whatever those fees are, because they're probably going to be insane. But as long as we do the math, then we can like scale and then still grow the business, and then that would buy us time to where people can at least use the cloud infrastructure, even if we don't particularly make money on the people hitting the scaled resources because of the cost of that. But it would give us give us time to get a new property, build out a new pipeline on that property, scale it out, build a new job there for someone, fund that person having a job in a home or something. There's a lot of things you can do with that. But what it does mean is that your pipeline can live in whatever form in any location, in any direction that you can code, basically. And you can use things like OpenStack, as this shows. You can have a combination of I currently like using VMware resources and Kubernetes and things like I'm sure you could use something other than VMware. I just I'm not a fan of VirtualBox at all. There's KVM2 and Kimu, so those are some additional resources if you wanted to like code entire like crazy things. Anyways, so let's see, security automation tools. Yeah, you can have multiple clouds. That's the idea. Multiple clouds and that work together even. So let's see, security automation tools. So this is just talking about just general tools. So this kind of covers some things it's kind of talked about before. So that, I mean, it's all relevant. For implementing primitives, let's see, so I'm just going to kind of move through this a little faster. Let's see, I keep saying that and then I see something that catches my interest. So I'm like, oh, shiny object. But let's see, the application architecture consists of other functional elements, blah, blah, blah. Well, let's talk about, so like five code types to be considered in the context of the reference platform. So let's take a look at code types. So if we're thinking about code, this is an interesting one to me, is I think about binary output before code languages. And when you're doing agnostic development, think more about the outcomes you want, not the code language that you want, because code languages all have guides in their own website. So I don't know how many people see it this way, and maybe this is a strange way to look at it, but if we were to like take let's take Golang and Python, right? Come on, thing. You can be my friend. Python. You can do this. So let's take Golang and Python together, and let's go to any of these. The reason why in agnostic development, I generally refrain from investing too much of my, like, I guess, memory resources, because it's a limited resource, toward like memorizing code, is, in my mind, in the context of efficiencies, there's documentation in these, and that meaning that I never have to remember how to install Golang because there's a guide for it. Therefore, it, in my head, is inefficient to ever even consider memorizing it. And then the more you do it, you get muscle memory. So in my head, I say just go and follow a bunch of guides, and after enough of it, and making something that you wanted to make that has the general outcomes and outputs that you're looking for, it's generally like a real world result based on a use case that you come up with, then by doing it enough, you'll end up with muscle memory, and you'll never have to actually invest in trying to memorize an actual language. You'll just get it into muscle memory that way. And then you can just do and develop code language by doing and not learning code. Skip learning code and instead just go straight to the guides, and maybe just follow a bunch of exercises at first. Maybe go get a Raspberry Pi and follow the Python games and just start doing some things. Or just decide that you want to make a product and just start making one, knowing nothing about what you're doing but Googling and hoping, and probably doing it mostly wrong, but that makes you learn real fast. Not to say that that's the best way to learn, but I think about it that way. So code types in reference platform and associated CI/CD pipelines. So with a reference platform, you might have multiple types of code. So you might have Python and Golang, or just Golang. But one way or another, you're going to have like a repository, things like that. Two, a CI/CD pipeline for the application code. So you're going to have a pipeline for the code. Then you need a CI/CD pipeline for the infrastructure as code. And then that's where you're like deploying containers, and you can deploy like virtual machines, like OVAs and things like that, whatever you're trying to do. And then CI/CD for policy as code. So policy as code is where you have policies where if it's a policy, you like put it in the workflows of how something operates or how someone interacts with the thing, is kind of how I see it. And so policy as code in my mind is forced clicks where you don't give people an option to follow the unsecure path. And then if somehow someone gets from outcome, or from opening application A and then gets to outcome B, somehow not following the standard process, generate a flag that says that somehow someone got around following the standard conventional policy path. And then instead of chastising the user and saying don't do it that way, go back and engineer your code to prevent that. So it's kind of like, I think of policy as code as don't chastise your users, instead just build better fences, I guess. Don't chastise your users, build better fences, and just guide the herd better. You know, it's maybe that's a weird way to put it, but when you make your users anxious, you end up with complications that you don't want. Some of those complications can turn into advanced persistent threats, and in my opinion, I would say that there's a good degree of advanced persistent threats or internal, what you would consider insider threats. I would consider a good percentage of insider threats self-created. If you're a business owner, think about that. If you ever get an insider threat, your first thought should be, did I create this situation? And you'd be surprised, because I've been through a lot of those numbers, and oftentimes you'd be surprised whose fault it might have been in a certain thing. But then fault is also subjective, so maybe it was no one's fault at all. Maybe it was everyone's fault. That also happens. And all kinds of things happen. I don't know. You work in cybersecurity, you'll see anything. You name it, you see some crazy things. People will find a way around your fence. So that's why I say just like code it so that you can just like, wow, okay, get back over there. Don't do that. Okay, good. No, get back over there. Just like keep it that way. So anyways, then finally observability as code. I've been talking about that. So it's like I would say observability as code is the future of monitoring technologies, because I work in data sciences and monitoring technologies and help build, deploy, and deliver monitoring technologies of various sorts from various different types of platforms, various different types of ways. And what I can say about observability as code is that it automates a lot of those things, and there's a massive community working behind those automations, and it's rather remarkable to watch. My favorite one still, that like my favorite project right now, is probably Loki. I don't know how many people have played with this project, but I love this project. If I'm just going to be really honest about this, I think this is like one of the coolest projects that I have seen. And while I've run into some problems with certain things with it, and maybe I wouldn't recommend it for like a beginner at all. Maybe, I don't know, maybe the newer updates have made it a little easier to dive into. But if you do data science and you like having like a portable like data analysis layer that's easily extensible and works with Prometheus and can integrate with like things like Prometheus, and you can also integrate it with like Logstash and things like that. You can integrate it with all kinds of things, really. I think you can like integrate it with like Datadog. I don't know, like this thing is, I love this tool. Like, I am very biased about this tool in particular. Do I think it's the best thing since sliced bread? I'm not so sure about that. Do I think that it has bugs? I absolutely do. Do I love using it? I really do. Whoever made this, if anyone ever sees this, who made this tool, any of you, I should probably go connect with you, because I think this is pretty cool stuff. So good work on all of you. I think that's some sweet stuff. Anyways, anyone and everyone should consider some Loki-based observability if you have it in you to sandbox. So anyways, moving on from that, since that's just my opinion, implementation issues for all CI/CD pipelines, irrespective of code types, will be addressed in the section. So let's see, securing the pipelines, workflow models in the CI/CD pipeline. Yeah. So let's see. Implementation issues. Section 4.6. So I'll have to look at these sections, I guess, a little further down the line. This section will also consider the benefits. Okay. 4.6, 7, and 8 up ahead. So I'm just going to move on from that. So let's see, code types in reference platform in association with CI/CD pipelines. Monitoring component, logging aggregation. DevSecOps. So let's see. I'm just kind of seeing what in here is worth kind of commenting on a little bit. So DevSecOps methodology, developing, testing. This is a pretty decent methodology. CI/CD pipelines for application code. Former contains data. Yeah, and then infrastructure, policy, and then observability as code. So this comes down to where we get to logging. Loki is a logging resource, right? Promtail is associated with logging too, so you can get Loki. Here, I'll link Loki here. I forgot about this, so I'll paste Loki in Facebook. And there's another resource called Promtail, which I don't know if I'm the biggest fan of Promtail. But you can also use FluentD with Loki, or Fluent Bits. One of the two. I don't know. I don't remember which one. But Promtail works. I'll paste this in the Facebook group too. Promtail works with Loki for logging. They're kind of built for each other. And then we go to the document again, and we have logging, tracing. So, following application requests, you can use a combination of Prometheus and Grafana for this bit, and you can also use Grafana for this as well, if you're ever curious. I mean, there's a lot of ways to accomplish these things, but yeah. Policy and observability code types span the following components. The service mesh. Yes, so this is I see. So I need to pay a little more attention to sidecar proxy architectures. I will make a request to anyone who's watched this much of this to catch this very specific request that I have right now. Is if anyone finds good information on like sidecar proxy like architectures, I'm very curious. That's the thing that I'm currently spending a lot more time wrapping my head around. I know a lot of things, but I don't know everything, and because the things I want to know are so complicated, there's not a lot of things I want to know. But one of the things I do want to know about is more about architectures around sidecar proxies, because that's about all the brain capacity I have right now. So let's see, these house encoding policies related to session, enablement, routing, authentication, and authorization functions. Yeah, policies. Okay, yep, this makes sense. So control plane. This is interesting. So control plane. So I'm just going to read this and we'll talk about this section. So this houses code for relaying telemetry information from services captured and sent by proxies to specialize monitoring tools, authentication, certification generation, and maintenance, updating policies in the proxies, monitoring overall, blah, blah, blah. So control plane monitoring, this is something that if you're using certain kinds of routing meshes, this is where you can also leverage resources like the Ponagachi, if you're using routing resources, to just make sure that certain things are not happening, ideally, and it's better to let the Ponagachi find out before someone else does. So, anyways, this is use case specific. If you don't have an environment that works with what this thing accomplishes, for whatever routing systems you're leveraging for your mesh design, then because we have some Wi-Fi access integrated and associated with our ecosystem, and so there are reasons behind that, but once again, you want to keep your stuff secure, because by having certain things like that, you're opening vulnerabilities if you're not monitoring and testing against those items. And if it's something that you don't want to spend a lot of time monitoring and watching, then you can have something else do the hard work for you so that you're not doing all of that work. And that's a resource that I don't honestly feel like putting 100% of my personal time into, so I'd rather let the AI do it. So then I can then set up a monitor on the AI, which to me makes life a lot easier, because then that's associated with some of the management around the control plane that we operate upon. So it's also it's complicated. The control plane that we operate on for our service mesh is interesting. Anyways, that makes sense. I guess I could comment on the use of AI here, because we use a lot of AI in our control plane management. I guess I'll say line 885 AI commentary. Okay. Anyways, this is a chunky document. 4.2. Pipeline for application code, application services code. If you can't tell, I'm getting tired. This is a lot, but we're doing it. I'm not stopping until we're done. I have more to get through for this, so no matter how tired I get right now, we're powering through this. Oh, I need to look into Linkerd. So for those who are not in the Facebook group, there's a comment on something called Linkerd. This has caught my eye in the past. I don't know much, if anything, about it. But once again, there are things that I want to know too. Just because I know things doesn't mean there aren't things I want to know, because I feel like there's significantly more that I don't know than what I do know, by a lot. And what I don't know is what this is. And this is what I want to know more about this now. So, well, I bet we could add this to our management layer. Anyways, I'll wrap my head around this a little more later. So this kind of, let me finish getting through this stuff. So this is good stuff. Let's see. Okay, so CI/CD pipeline for application code. So we build pipelines. So I guess I should think about if there's anything that I feel like they're missing here. Maybe not. Let's see. So this pipeline should be protected using outline stepped and. All right, so this is telling me that before I can make a conclusion on this, I need to read 4.6, which it was telling me earlier too, and some issues. So this is actually also a way for me to validate the architecture that we use so we can improve our architecture. Because while there's a lot that you can see that we've done on this, one of the benefits in why I am saying like this benefits me and why I'm focusing less on entertaining everyone and focusing on trying to get this out of the way for myself and for the business that we're building and that we run is because I have to do this. Like it's not like I'm a business owner. It's not like I'm just like playing patty cake and like, this sounds fun, everyone. We're going to make some cool videos. No, this is my life. This is what I do. It's what I suffer through in my days. You wonder, where is NATO and why don't we ever see him? This is where I am suffering all the time. So maybe you'll see me more often doing some of these things. No, I do like this stuff. It's not that I don't like it. I love it. There's a reason why I've taken it this far. But yes, we do need to pay attention to, I guess, section 4.6 and 4.8. So let's see, the advantage of this type of tool complexity exists in the platform's native security measures, such as access to the control models and pod security policies that prevent violations. by actually detecting them when. So okay, so what this is saying is we need to build a base detection system, which Pi-hole to an extent does, but that's very base, right? So that's like we made something that gets us off the ground. So we barely make this requirement right here, but not quite, because it's not a true cloud native app. So then there's a little supplementation that needs to be added here that this is outlining, is what this is telling me. And we have an engine for it, which is something that I'm not pulling up because that has like private data and stuff like that. And that is my resource that sits in Loki and all that good stuff with like Promtail, all that good stuff. So this is good to know. So that just means that there needs to be some detection code that's associated with certain violations, right? So I need to determine what would be designated as a violation. So then that goes back to, why do I need to pay attention to sections 4.6 through 4.8, and that's going to outline the rest of what I probably need to fulfill that. So that's how I see that right now. Let's see, 4.3. Pipeline for infrastructure as code. So infrastructure as code, codifying. The software containing this code type is called a resource or deployment manager. In other words, IAC software automates management of the whole IT infrastructure lifecycle. So this right here is the this goes back. So this goes back to what I was talking about, the Olympiad dev up here. 4.3 outlines what this is designated to do. That's how that's kind of built out. Now, once again, I have work to do on this, so if you're trying to use this, notice that like you can fix the problem with Portainer in here yourself if you know how to do that. So I will just tell you, for anyone who just wants to play with this and wants to know the solution to the bug, is just the port mapping to Portainer on the inside change to 443. I wonder if I could change that right now. You know what? I'm going to change something, I think. Give me just a sec. So let me update this repository. So I'm going to do a pipeline update right now and fix a bug live. Why not? In seconds. You don't even have to know what I fixed. It's that simple. It's so simple to work in Cloud Native that you can just fix what you want. All right. Anyways, so there'll still be some tweaks. Just know that everything would work if someone wanted to tinker with this. What I might recommend is just deleting and redeploying Portainer and redoing the port mappings after it builds itself. And someone who's worked with these types of resources before would know what I mean. If you haven't, then just wait till I finish doing the updates. But I just completed it. So at least now it'll work. So if you pull it, it's gonna get it'll pull everything in, and you will then run into a scenario where you can't connect to Portainer still, but you can go inside of it. And the way to access the inside of it is to go over to, I want to say where it says, I think the container is going to call itself, what does it call itself? Olympiad 0. No, that's going to be the, yeah, that's the one. So the container that calls itself Olympiad 0, where it says 9,000 right there, it's you got to change that to 9443 on the revision. And to do that, after deploying it, the easy way to do that would probably be just using like docker exec commands or something. Anyways, someone can message me if they want to figure that out. Otherwise, just wait. I'll do the rest of it later. I'm redoing all this anyways, so it's going to deploy itself differently soon anyways. So we came up with a reworked delivery system. So the current delivery system is technically about to be deprecated. So I will say that too. So if you put a lot of effort into Olympiad dev right now, I'm putting an update that I'm not. This repository won't be deprecated, but some of the components in here that were used before are going to get deprecated out because this has some backbone resources that are supported right now, but I'm switching the format. Anyways, that doesn't matter. Let me get back to. It's all relevant because it's our CI/CD pipeline. And the other thing is we do use a combination of VMs and containers. So we use both, and we also use a resource called BuildX for agnostic development. BuildX is awesome. I love BuildX. It's like one of the coolest tools I have ever seen. So anyways, CI/CD pipelines, so one of the tools that we use with our pipeline is Terraform. And if you've never heard of Terraform, the reason why Terraform is because Terraform can also be used to provision, and it's open source, you can use it to provision bare metal. So oftentimes what I'll do is I'll use Terraform on bare metal and for VMs, think resources like that. And then I will use Docker files for extensible code, including staging Kubernetes. Let's see. So that's the thing. So think about Terraform in the context of that item, I guess. So anyways, Terraform is something that we use. I like Terraform. I'm probably going to rework how we integrate it into the platform though. I'll probably put it where I don't know, I got to figure that out. I might even I have some thinking to do. Anyways, doesn't matter. So continuing on with some of these thoughts, Terraform is what we use for strapping bare metal with our infrastructure's code. Anyways, sometimes I'll use Docker files with injection code because Docker files can also execute Bash files and scripts and things, and then you can use YAML files if you want, depending on what you're trying to do. Docker Compose, you can, and then you can, just a lot of stuff you can do. It's just like unlimited options. So comparison and configuration. Okay, so this is a interesting comparison, but I think it makes sense what they're trying to say. The idea is that a code pipeline, I guess, to what I'm kind of interpreting this as, is that instead of having, say, like a data center where you have teams and networking cables, you basically kind of have more of a virtual experience with this other development format, more or less, where you're like coding networks instead of wiring them, I guess. So anyways, CI/CD pipeline policy as code. And we have a policy categories, example policies. So category, it's a nice little table here. So talking about this table, they produce like what are different types of policies. So zero trust policies can be built by defining unique networks. So inside of say like Docker, you can define unique networks. So you can go over here and say network, and you can have a policy that things have to operate over certain types of networks, whether you have one that's, I have this little zero trust test right here that has a specific node trapped on it that can't really talk to the other nodes. And then, this then is an isolation policy saying that this node is stuck in a network policy that basically says it can't talk to all of these other nodes over here, right? And then from a security standpoint, what this then says is that these also can't talk to the other node because they're isolated and they basically have zero trust with each other. This thing has zero trust. This one node right here, this container, has zero trust with these containers. Period. So, and then this is all done with code, right? So it's policy as code. This is just a sample. I'm just giving you like one tiny little sample of like there could be like a million ways to do these things. Anyways, implementation of artifact policies. Ensuring that containers do not run as root. Storage policies, access supply chains. Yeah, so artifacts, this kind of outlines what that is. Just make sure that you don't have things. You do want to ensure that your containers are not actually running as root on your production systems. Like when you're testing and stuff, that can be fine. But then, this kind of talks about like, what are your policies? Blocking privilege escalation for containers. Now, if you have certain containers designed a certain way, then once again, you just want to keep these things in mind. Like privilege escalation matters. Understand how it works. Pay attention to it. And don't give things privilege where they shouldn't have it. And then storage policies. So in the context of storage policies, you can set persistent volume sizes. And anyways, you can use resources like Longhorn for building storage policies. I think Longhorn's a great resource for building storage policies. That's what we use. That's what we're using. Longhorn, Randall had linked it earlier, but let's see, Rancher Longhorn. It's a neat little tool. There are other tools like this, but Longhorn, if you look up Longhorn Rancher, persistent storage with Rancher, learn how this simplifies distributed block storage. I love Rancher and Longhorn. I like K3s Kubernetes, it's by Rancher, and Longhorn is also by Rancher. But Rancher makes some sweet stuff, and Longhorn is outstanding for building storage policies. So anyways, building and managing storage policies. And maintaining them. And scaling them too. So, because you can scale your storage with all of that. So access control policies. So however you manage your access control, using a VPN or not using a VPN is an access control decision, right? And so that would be an access control decision. Supply chain policies. What are the approved container registries for what? And what are public, what are private, how are they distributed, how is it structured? And then, what are the certified libraries that you're allowed to use for development? You should qualify what your certified libraries are. So that's something that you'll want to think about. So your what this means is that you don't want to just go over and be like, okay, so I want WordPress, and I'm going to just randomly choose any old random thing without even giving it a second thought. And oh, this looks great. I don't know who made this. I don't know where it came from, but I'm going to just use this for my supply chain. This is a bad idea. Don't do it. Not without like a validation process. You can use other people's community resources, but use a validation process. Test it first. Have a development environment that's separate from your production environment. Don't mix the two. Use zero trust as a policy. and make zero trust policies separate your testing infrastructure from your production infrastructure, and make your things like your social infrastructure, like my stream system, separate from my cloud infrastructure. And then we have other sets of infrastructure that are separated for various reasons. But you want to keep your supply chains isolated, separate, and easy to monitor. The more separate and isolated, and then like follow validated processes, use things that, like, if you're using like verified repositories, now you don't have to trust my repository, but one way that you can kind of play around with the resources that I do use is there is a repository called Docker in, maybe I just type Docker. There's one that's literally just Docker in a container. Here it is, Docker. I think this is the one. No, that's Docker registry. Oh, yeah, Docker. Docker and Docker. You can literally just like shove Docker inside of Docker, and then you can throw Docker containers inside of Docker, right? So going back to our document, if you wanted to build the kinds of structures without even using, say, like my repository, I even start with like Docker and Docker resources. It's not obviously not unique. So like, how many people do this? This has 1 billion plus pools. So at least 1 billion people also use this resource. So it's not magic. It's been used billions of times. So a lot of the things that we do and that we deploy have been used and deployed billions of times. That's the thing to think about. I say that also because I don't want anyone to think that this is like stuff that we've just like fabricated and made up or whatever too. But like, it comes from somewhere. It's not there's a reason why we use it. We don't just use random processes that just sound cool. We go through significant amounts of validation so that other people don't have to go through all that validation, because that validation is so time consuming, and you can do all the work that we've done on your own too. And then that's called community if you want to contribute to the community, and I'm all about that. So there's tons of people who have outstanding resources around this stuff. The policies defined in the policy as code software may translate into the following application infrastructure: runtime parameters, policy enforcing executable, basically like WASM in service proxies, triggers for calling external policy decision module. Yes. So anyways, this is all fine. So let's see. Pipeline for observability as code. So we're approaching 4.6, which is the thing that I think I need to pay the most attention to, and then we can kind of just move through the rest of the document, kind of close out the session. It's been good. It's been a long session. So let's see. Observability as call applications service components to collect 3 types. Okay, so yeah, this talks about the 3 types of data. Send them to specialized tools to correlate them. Once again, I love Loki for this. I think it's amazing. Data group. The data are grouped into clusters based on common patterns. So you can do all of this stuff with Loki and Grafana. Cool thing about Loki is you can have multiple Loki databases that like work together. You can build it out as a service, so it can be distributed ingestion for monitoring. It's pretty neat. It's fast to configure once you figure out how it works. There's other solutions. There's like Elk Stack. There's like Splunk. There's, I don't know. There's so many logging tools. There's like, I don't know. There's like millions of logging tools. No, there's not millions. Anyways, there's just enough. A logging tool logs. 4.6, securing the CI/CD pipeline. There are some common implementation issues to be addressed for CI/CD pipelines, irrespective of code type. The first, security, involves Securing the artifacts, including hardening the servers and nodes used for generating. Yeah, so hardening is the first thing that you generally want to do. So harden your code. You can use Docker and Docker for hardening. I don't know if it's the best way to do hardening. The best way of anything, I think, generally, like, look things up and see what you think and see what you can find and develop an opinion on what you would think the best is based on whatever use case you're looking for. I think best is very use case specific oftentimes with things like this. So I'm always careful about saying something might be the best for something. So let's see, the following security tasks should be performed when securing the CI pipeline. Authentication, yep. Logging, building reports, yep. Sending build reports to developers and stopping everything. Yeah, this makes sense. So securing the CI pipeline. Multi-parties. So anyways, okay. So this is just outlining, like, what are the security tasks that we need to keep in mind. And then securing them requires, multi-party signing with basically authentication to sign into CI/CD pipeline phase. So there are different ways to achieve that. That makes sense. It's kind of like using a VPN technically is not enough. It's, you want to have whatever security means you have, like multi-factors, all that good stuff. And then having multiple keys, that goes back to multi-factors in general. So basically just secure your pipeline. So that all makes sense. So workflow. So I guess, so this is a good thing to outline. So if you are using, say, like code repositories, depending on how you have a repository set up for production, if you have, say, an app and it pulls data from a location but never pushes data to that location, what that would then mean, if that device got breached because it's a pull-only design, that data, if something were to breach it, it's not going to push anything back up to the source of which it pulled it from, depending on the design. And then, like, push designs, it's that introduces levels of risk that need to be understood. So this makes sense. And, Docker Hub is filled with vulnerable containers. Even the ones I make are vulnerable. So you have to know how to make your stuff less vulnerable, because there's vulnerabilities out there. So let's see. Just GitOps repository builds is therefore highly recommended. So this saying, using a GitOps repository for storing source code is highly recommended. This kind of goes back to why I like resources like GitLab. GitLab is great for this. You just toss your code into GitLab, and then when you need to modify things, you can just, like, go modify it right there and then just send out your updates. And then let's see. So like with a pool-based model, when you send out updates, then anything that's pulling from that repository gets your updates. That's kind of what I'm saying, I guess. That's what I'm trying to say. So anyways. Yeah, so this just basically recommends using resources like having a GitOps presence. There are a number of great tools, Argo CD, Flux, things like that. Anyways, let's see. GitOps workflows for CI/CD. Under the cloud native landscape, what this is talking about in that category for, like, securing your cloud or your cloud native project, this is talking about continuous integration and delivery in that section 4.7, where it was talking about Argo being a good resource for CI/CD like as a pool-based resource. That's basically what that's saying, to my understanding. I could have read that wrong. But anyways, so I guess that'd be section 4.6 that's saying that. So getting into 4.7, let's see, pool-based model. Yeah, this is just kind of talking about things I've been talking about. GitLab's great. Yes, you know, you're building a supply chain and a proper CI/CD structure. It's super time consuming, but it's worth it. It's painfully time consuming, but like once it's there, it's there. I think I see oftentimes the effort in this section get missed because it seems inconvenient and like it might slow things down or put projects at risk. It doesn't. If you just pump the brakes for a while to build out some of these structures, then by the time you finish building some of these structures, you can just like catapult out code so fast, and in a format that's designed to be secure by design and in format. So it does increase the rate of output and lower the risk at the same time, and it lowers the complexity to build, as long as there's a willingness to patience up front, which people need to have a willingness for patience up front, which companies, it depends on the culture. Some companies don't believe in patience, and then it doesn't usually turn out well for them. But that, if there's a company like that, maybe don't stay there too long. So 4.8, security testing. Common requirement for CI/CD pipeline for all code types. So I've kind of talked a little bit about this. So we talked about SAST tools mostly, a little bit anyways, but basically you want to have analysis tools. That's kind of what this is saying. You can accomplish this with like scanning tools like Nmap and things like that, and beyond, more than that. It's not just like the only thing that can be used in that category. And then you can integrate some of those tools with some of those other tools and build dashboards that are DAST based and automate them even. And Loki and Promtail can interact with both SAST and DAST tools because of how logging works with your observability. So you can apply observability to category 1, 2, and I guess 3 here too. Is just, yeah, I guess this is just combining them, is IAST. Combine DAST, I guess, with the instrumentation of the application under test. So I guess it's not a combination of this plus this. It's DAST plus instrumentation. Okay. And then we have software. So basically you want to use vulnerability scanners. That's what this is saying. Use them. That's mostly the point. Great. Let's see. Vulnerability scans. So you do want to scan your container images if you're doing actual business for vulnerability so that you know what they are. You do want to do routine vulnerability scans, and also you will inevitably have to do regulatory compliance scans whether you want to or not, unless you like fines, and then otherwise you just pay the fines. But some of those can also turn into jail time, so be careful what you decide not to try to run scans for. So just run your regulatory and compliance scans. It saves trouble. So vulnerability scans are to be performed whenever the code in GitHub is revised to ensure that the current revision does not contain any vulnerable dependencies. So going back through this. So overall, let's see, benefits of primitives, DevSecOps primitives. So this is talking about some benefits. So I guess I might think about if there's any other benefit that they haven't thought about here that might come to mind, but this might be pretty good. So let's see what some of the benefits are. Streamlined software delivery, that makes sense. Reduction of the number of silo. Yes, this is a huge one, honestly. Siloing can wreak havoc on small companies. Reduction of attack surfaces by implementing zero trust. Yeah, that's a good one. Introduction of, yep. So reduction of lateral movement because of little zero trust. So this over here is a lateral movement simulation and tracking thing. Well, it's thinking about it. Yeah, all of this is lateral, like based on lateral trust analysis. That's kind of how that's built. So let's see. Faster reduction of lateral movement, increased communications between team members and other stakeholders. That's a good one. Faster incorporation of feedback resulting in quicker software improvements. Automation of repetitive tasks. This is always a big one. Less downtime. Faster time to market. I agree with this so much because I look at different projects that I'm associated with that are DevOps versus DevSecOps based, and the DevSecOps based projects move so fast. Like they all move so fast. It's not even just like one DevSecOps based project. Like in comparison, they move so fast. Let's see, infrastructure for continuous software development and delivery. Yeah. Yeah, the cost of infrastructure. I feel like this needs to be a little more specific. Like it says benefits, infrastructure for continuous software and delivery, as well as admission controller. I don't know, that's a little confusing. So maybe I put a comment on clarification on this. Line 1124. Okay. 1, 2, 4. Clarify. And I think that there is an opportunity here for, let's see, maybe also add after this to consider. So some things to consider is lowering cost of operations. It depends on how it's designed and structured, because labor costs can go up in place of infrastructure costs. Lower infrastructure costs though. Like part of what makes it have a faster time to market when developing with cloud native is minimum viable products can be more minimal. Therefore, you need less infrastructure to get off the ground. Yeah, so infrastructure costs. Okay, so yeah, so validation of requests, that makes sense. So you have to build validation processes. Feedback mechanisms, that makes sense. So leveraging DevSecOps and continuous authority to operate. So the idea behind continuous authority to operate is also just kind of under the idea that if you're building a continuous technology, part of that authority is your capacity to engineer like stable technologies, right? So like reducing outages. So the idea that, say, Google sometimes has outages, Microsoft and Azure sometimes have outages, AWS does, Facebook does, but the less the downtime, the more the continuous authority. And so the idea is that through distribution and having distributed processes via a service mesh based design and architecture increases your capacity for continuous authorization to operate overall. It like increases capacity and potential for scale too. So let's see. And then it also has to do with, having processes in place for checking compliant code, because that also matters. You can't, basically anything that puts your operation at risk, it's more than what I just described. I'm watering down one minor element of what I'm talking about. But then anyways, like generating dashboard and displays that shows runtime statuses, it all plays into the same general overall goal of producing continuous output. Continuous output that is reliable and sustainable and ideally isn't going to go down and ideally isn't going to let you down. So that kind of gets down to the end of the document. And we have a whole bunch of references in here. I'm going to wrap up at this time. Certainly feel free to read the summary on your own and read all of the references if that's what you would like to do. But thanks for listening. I'm going to go ahead and button this up, so I do have to put this together still, so my day is not going to end. But your day can end if you've been watching and you no longer have to suffer through commenting with me. So anyways, I'm going to get moving into building out some submissions and things like that. And thank you for watching. For those who find this interesting, if this is something that's helpful enough for folks, since like I know that other people have to do this and it's not all that exciting, so it's like maybe it's more fun to not do it by yourself, then maybe I'll do some of these things more often so that when people do have to do this stuff and like rub your face against like the sandpaper and stuff, that at least you don't have to do it by yourself, because that's, I guess I'll do it with you. So anyways, thanks for joining, and I'm going to go offline now, and I hope everyone has a great